So that's the basics. If you wanted to take off a top 1000 and instead of having star, say just first name, comma, last name, those are the two columns we want. Notice the comma separation. We execute that. Notice now that we have first name and last name. And in fact, if we wanted to, we could say as first space name, as surname. What this as syntax does is allow us to rename the column. So if I execute this, now notice first space name and surname. It kind of blends in together, but it does say surname. So we rename our columns in our queries. That's very helpful because we can separate then the display to the user from how we store it in the database. And so we can actually hide, obfuscate, change, or improve the names of our columns right in our queries. Now again, there's so much more I can show you here, but this isn't going to be a deep dive into SQL. See my SQL from start to finish course for that. Instead, I just want to give you an overview of this syntax because next we're going to create all of our store procedures. Now a store procedure, its job is to link together or expose a database script or a table script to the end user in some way. And so I use store procedures for just about all of my data access, in fact all of my data access, because it allows me as a SQL developer to secure my database much more thoroughly and make sure that bad stuff does not get in your database. If you're familiar with SQL injection or all those type of attacks where people actually access from your front-end application, they access your database and destroy stuff or change stuff or access stuff, that should probably scare you. But if you use everything through store procedures and then properly secure your database, then the hackers have very little to no access to do anything you haven't explicitly said they can do. And I love that. And so whenever possible, I develop directly to store procedures, not to views, not to tables. So a view is like a query. That's up here. I typically don't use views, or at least not often. Instead, I go right to store procedures. So to create a store procedure, there's no fancy editor, unfortunately. Just right click and say new store procedure, and you get this. And that's a little complicated. Now you can take the comments out if you want. Makes it a little cleaner. That's just who created and when for what. But you still have this. I'm going to show you a little bit cleaner view that it's a little less scary, hopefully, and it actually has some relationship to our current tables. So let's go ahead and I'm going to add those store procedures in, and then I'll come back and I will show you how to actually look at them and even design them. Be right back. All right, I'm back. So I've created these store procedures here. There's, I think, 7 of them. Let's go ahead and look at this store procedure. Right click and say modify. That's probably the easiest way of looking at it. One of the benefits of saying modify here is if I say, you know what, I need to make some changes here, I can go ahead and change this in any way and run it because it's already set for alter. And so that's the first thing I'll look at. Ignore this stuff up here. And then also this right here, use tournaments, go, is just saying make sure you're in the tournaments database right up here. Because if you're in the wrong database and you add the store procedure, that's a problem. So, but we're in the tournaments database. So I called this, so alter procedure. When I first created it, I said create procedure. And that creates this procedure. Notice the red squiggly says, hey, there's already a store procedure of that name in the database, and that's because we've already created it. So if I want to change it, I have to change this to say alter. And that's all I have to do in order to then make modifications to this store procedure. I call it dbo.sp prizes underscore get by tournament. So this is for the prizes table. I'm saying get the prizes by tournament. So get all the prizes for this tournament. And then this is the value I'm passing in. So I'm passing in int, and I'm calling it tournament ID. Think of this as your parameter in your method in C#. So this is your method name. This is the parameter. This is the parameter type. So we have then the as and begin. This is begin right here, and then end right here. Everything for the store procedure has to be between these two blocks, between begin and end. Again, think of these as curly braces. All right, so no count on. What that does is it doesn't send back to the caller the count of how many rows occurred, and that's fine. Just set no count on, just says don't send that extra bit of information unless you wanted it. If you wanted it, then you'd take that entry out or set no count off. But in most cases, I have not found this necessary to send back a count. Especially when you have a select query returns data. So if it returns 10 rows, guess how many rows were returned? What? 10. We can count. So there's no reason to have it send back two pieces of information when just one will do. And that one being our actual data. So in this one, I'm saying give me all the information from the prizes table, but then I'm joining it. And that's a little more complex. And so I'll walk you through it. Again, select, well, p dot star instead of star. Why p dot star? Well, I renamed the dbo.prizes table to be just p. That's the rename right there. And that way it makes it shorter. So instead of saying dbo.prizes.star, I say p.star. Makes things a lot easier. Why p? Well, p for prize. And then I'm doing the inner join. And what this does is it connects two different tables. And I'm connecting them based upon the prize table, its ID, so p.id, equals t. T is the dbo.turnipPrizes renamed to t. So t.prizeID. It's just that same relationship we set up earlier. We're using it. We're saying this is the connection here. And then saying where t.tournamentID equals that ID passed in. So what's happening is I'm saying let's find out the link across these two tables and then only give me the prizes that are in this particular tournament. Now again, it's going to take a little bit to understand that, and that's fine. If you're confused, don't worry. You just have to use this, not necessarily understand it yet. Down the road, if you want to understand it and if you want to do more with actually creating store procedures, which I would recommend, then go ahead and watch my course on C# from start to finish. So this is our store procedure. Now, how do we call it? Well, it's a little different, and there'll be a little bit different in C# as well. But let's create a new store procedure, and then we'll call that. Since we have this, the test person table with sample data in it. So let's create, right-click on store procedure, and say, notice, by the way, that is inside of the programmability folder. Then store procedure. So right-click and say, new store procedure. Let's get rid of all the stuff we don't need first. When I create store procs for my company, I actually fill this information in or create a similar template and use it. But in this case, we don't need to do that. And then let's pass in or give it a name. So I'm going to say DBO. Now, what's DBO? Well, that's database owner. Notice that all of my tables have DBO dot. All of my store procedures have DBO dot. By default in SQL Server, DBO is your primary owner and primary schema for your tables and store procedures and views. You could change that, and in fact, if you use a sample from Microsoft, you'll see all kinds of different schemas. Instead of DBO, it'll be person dot or address dot or company dot. That gets a little confusing, and Again, for a rookie person just starting out with SQL Server, don't worry about it. Put everything in DBO. So create procedure DBO dot, and let's call this, I always start SP. Don't do SP underscore, but SP. SP underscore will confuse the system into thinking this might be a Microsoft supplied store procedure. And that's not good. It makes things longer to try and figure out, and it could have some naming issues. So let's call it SP test person underscore get by last name. Now parameters, let's go ahead and wipe all this out. And let's wipe out this comment as well. And we will wipe out this as well. So it's a little more bare bones. Now in the parameters here, I want to bring in one parameter, and that would be last name. Because I'm going to get the test person by their last name. If there's more than one person with that last name, it'll bring more than one record back. So we will say at, because all variables in a store procedure should start with at, last name, we'll say space, and varchar 100. Now, if you're not sure on the number, how big your last name should be, you can right-click on test person, go to design, and say, yep, last name was 100. You could specify in your store procedure less than the maximum. If you specify more than the maximum, you'll have a problem when it comes to inserting. So, but less than is fine. Equal to is probably the best, since it's the same limitation, but it's really up to you. So last name, or at last name, space, and the type. If we had more than one, we'd put a comma here and say at, say first name, or whatever. But in our case, we only have one parameter being passed in. And then down here inside our begin, before our end, we will say select star from dbo.testPerson. Now, do I need to do dbo dot? Technically, no. If I don't, then the system will say, I'll think it's probably dbo. And so it'll assume that and prepend it. But in this case, it's probably just a little cleaner to say dbo.testPerson, where last name equals at last name. I'll put my semicolon to be complete, and we're done. That's our store procedure. I hit execute, and it says commands completed successfully. And at first, you might be thinking, if it's late or whatever, you'll think, wait, what? Why don't I see data? And you don't see data because this doesn't do data yet. What you're doing is actually creating a new store procedure. You're just creating a new entry here. If we hit refresh, you will see that test person get by last name is right there. And if we create a new query window, I can call this by saying exec dbo.sp test person underscore get by last name. It's not there, so it's going to yell at me, so I have to refresh. And that's the Control-Shift-R, so it takes a bit. And I can say query. Now, even if the squiggly is there saying, nope, didn't find it, you can still run your query. It will still work. It's just that the editor hasn't caught up to the fact that there's new objects. That Control-Shift-R will do the refresh. It'll take a couple seconds. As you saw there, it took, 15 seconds or so before it actually refreshed our editor. Closing and reopening also works. So I'm saying exec, that's how you execute a store procedure. The name of the store procedure, the full name, dbo.sp test person underscore get by last name. Case sensitivity is not a factor here, so it could be all lowercase if you wanted to. And then after a space, I put my parameters, and I can either put them in order, or I can say at last name equals like so, and then comma separate them that way. I guess you should do them in order, and that seems to be fine for me. If you execute, notice it now says Tim Corey. And if we look up, I forget what the other person's name is, so you can select star from, and it's Jim Smith. So last name was Smith, and we execute that. Now Jim Smith is down here. So based upon what we select up here and run is what we get down here. So that's how a store procedure works. Now, one thing I haven't pointed out yet in the editor window, if I have this highlighted and I hit F5, look what happens. Could not find store procedure Smith. The reason why? Whatever you have highlighted in this window is what gets executed. So if I don't highlight the whole thing, then it won't run unless nothing is highlighted. If nothing is highlighted, then everything gets run. So for example, I could come down here. Let's just say select star from dbo.test person. If I can highlight anything and I hit F5, it executes the store procedure, and then down below it also executes our table, our select statement from our table. So both get executed. If I highlight just one, just that one gets executed. So that's another little tip for the editor window. So that's an overview of our database. That's really all there is to our database. I know it's a lot, but at the same time, it's not really. So I just want to give you an overview so you saw, again, this took over an hour to kind of give you a good overview of what's going on. But I thought it was important for you to get a good handle on things before you get into actually using this. Now, I don't want you to feel uncomfortable about later going into this and just poking around, seeing what you see, trying things out. Maybe you don't get as complex as store procedures, but maybe you can create a new table, try it out, maybe even try linking two tables together. I want you to feel comfortable at least seeing this data and seeing this data coming from SQL and not being concerned that it's a black box. Welcome to Lesson 9 in a C# from start to finish course. My name is Tim Corey, and today we're going to wire up our prize form. Now this is a simple form to start with, and it doesn't have many dependencies. Basically, it just takes data that you give it, it makes sure it's correct, and then it saves it to the database or text file. And that is where the first tricky part will come in. How do we know where to save it? Quite frankly, this is where you'll probably get stuck when you're trying to build an application. This is a spot that tutorials try to avoid or try to make sound easy. It isn't easy, but there is hope. We're going to tackle this problem head on because I want to make sure that you can know that you can do the hard things and that they can be made easier if you don't panic and if you break them down into very small pieces. Here we have our prize form. Now before we do anything, we need to plan out what needs to be done. You should always know what to do before you do it. And this is a great example of why. You see, initially this form seems simple. When the Create Prize button is clicked, this one right here, we take the data from these 4 fields right here, create the model, and save it. But where do we save it to? The database? A text file? Both? How do we know? Where does that information get set up? How can the code save to both types of storage without being, well, ugly? So let's start off with the ugly way that it might work. And let's just sketch this out in Notepad. And this is going to be a pseudocode just to kind of illustrate the first take at this, the first try at building this form. So pretend we've already done all our validation, because the validation is just simple. It says, is this a number? Is there text in here? Is this a number? And is this a number? And it's one of these 0. Okay, that's pretty simple stuff. And we say we've created this model. Remember, we have the prize model here. So we have that model. And let's just call that model, model. Okay? So we have that model, it's populated. Now what do we do with it? Well, we could say, if, and somehow know if we are doing a database using SQL equals true. We have our curly braces here. This is just pseudocode. It's not real syntax. So don't get overly hung up on making sure everything's right. But if we're using SQL, then open database connection, save the data, and maybe also get back the updated model, because we want to have, when we create an entry in a database, we get an ID for it. And so we want to have the ID back so we can say, okay, this particular prize is prize number 5 or whatever. So we do those steps and you'd say, okay, but then down here, if using text file, which again, we don't know where using text file or using SQL comes from yet, so we have to figure that out too. If we're doing that, if that's true, then we do something like this where we'd say open text file. We need to know the name of it and the path to it and all the rest. Save the data. But first you probably generate an ID, because text files don't create IDs. So we need to have some way of saying, okay, there's 5 records in the text file. The last ID is number 8. Therefore, this is number 9. Whatever it is. Save the data. And so now we've got the, if we're using SQL, it saves. If we're using a text file, it saves. And then we're done with creating this prize. But this code right here will work. Okay. Now, of course, you have to fill it out with real code. But this idea of a code, this is pseudocode. This would work, but think about all the places where we talk to our database. In every one of those places, we have to have code like this, where we say, if using SQL, if using text file, actually connect to the database. This form has to know what the database is and how to connect to it and all that kind of stuff. And the same thing with text files. It has to know about the text files, where they are, and all the rest. But so does the create team form. So does the create tournament form. So does the tournament dashboard form, possibly. And also the tournament viewer form. These all have to know about stuff like this and do this kind of stuff. That's an awful lot of duplicated code, and it's quite frankly pretty ugly. I mean, imagine if we said, okay, we want to change where we're connecting to the database. Well, now you got to change this code right here everywhere. Maybe we say, yeah, we're going to add MySQL as a database option. Oh boy. Every form, we have to now add a third if using MySQL equals true, and so on and so forth. For every form, multiple places for some forms, because some forms have more than one button. They do more than one thing. So this code isn't really scalable. It's definitely not dry, as in don't repeat yourself. So there's got to be a better way, and we're going to investigate that better way, okay? Because we don't want to write hard to maintain code that's quite frankly ugly and overused. All right, so let's start over. So the method that I use is to keep pulling the thread. Okay, what I mean by that is I take the issue and start asking questions. And sometimes I just write those questions down. And sometimes I get an idea or a thought and I'll write that thing down too as well. And then I start just keep working at it until I drill all the way down to the bottom of the issue, or to a place where I can say, okay, I can do this step, and then come back and pull that thread again. All right, so this isn't going to be easy because it's not something small. We're not doing just for this form. We're building a system that can be used by every form. What we do here determines what every other form in the database does. So therefore, writing things down and mapping it out means we're less likely to forget a step, and we're very, very clear on what happens. So the first thing you need to do is connect to our data source? So the question I have, and we're going to write this down, is this. How do we get that connection information? Remember in our previous pseudocode example, we weren't even sure where that came from. We just knew we were going to have it. Okay, so that's the first question that gets generated. But then that question leads to the next question is, how do we connect to two different data sources to do the same task? Okay, so part of this system, part of this application is we wanted to have the ability to save to either text files or a database or both. Okay, and so we want to be able to accommodate that, and really the actual act of saving is the only thing that's different. How we actually put it into a text file or into a database. But from this form's perspective, all we need to do is say, I have a model, save this. And then possibly get a model back that says, okay, we've saved it, and here is the ID along with the rest of the data you saved. Okay, so this form doesn't need to care if we're saving a SQL or if we're saving to a text file, or if down the road we're saving to MySQL. It just needs to care, I'm saving it. So the first question here though, how do we get that connection information? It sounds like we need some type of data that's accessible from everywhere in the application, and it tells us which data source to use. That sounds like a global variable of some type to me. Normally we try very hard to avoid global variables because they take up memory unnecessarily, but in this case we need something globally accessible for the lifetime of our application. And that's the exact definition of a global variable. So in this case, I'm thinking about using a static class to hold our data. Normally, again, you wouldn't store data in a static class because it's global information and anyone can change it. But since we want global information, I'm going to need to work on the safety part of the data, but I want to take advantage of the global use. And by making it a static class, I can keep all the global data in one place. So let's write that down, come down here. These are my questions up here. Down here I'll have just some notes. So I'm going to say that I want to have a static class for data source info. And this static class is going to tell me which data sources are available. Right now it's SQL or a text file or text files. That's going to tell me that and how to connect to those items. But before we build our class though, we need to address our second question. How do we connect to two different data sources to do the same task? The key here is you want to do the same thing, just with different data source. So if you need to do the same task, but behind the scenes, it will be done two different ways, you need an interface. Now an interface is a contract. What it does is to make a promise that any class that implements the contract will have the following items, whatever's in the interface. So those items are specified in that contract. Now I've got a video all about interfaces. So if you get a little bit lost here or you want to get some more information before we continue, go ahead and check that video out and come back. But the best way that I have found to understand interfaces is to create one and use it, or at least see one created and put in use, because then it kind of clicks what happens. So now we have, and let's write this down, we want an interface. We want an interface for our data sources. So that's the bare bones of a plan to get started. We're going to create global variables to hold the data source information by using a static class. And we're going to use an interface so we can call either data source the same way. Let's start with the interface because we're going to need to do that in order to build a static class. We're going to have that interface. So over here in my tracker library, we want to move all of our code, if possible, into this library. Don't forget that one of our requirements is that we might not always use this WinForms application to track tournaments. We may use other systems like a web-based system. And so the more logic we can put into this library, the easier it will be later to create a new user interface to do the same thing. So in our tracker library, and you could create a folder for this if you want. I'm going to create it right in the root. I'm going to right click on my project and say add new item interface. Now, one of the pretty hard and fast conventions for interfaces is they start with a capital I. And that tells you this is an interface. And that's really important when you're actually using an interface. And I'll explain more in a bit, but let's start by just doing an I data connection. So anybody that implements this interface is a data connection, whether it's a SQL connection, a text file connection, or later on down the road, maybe a MySQL connection. And this is an interface. So the first thing I do is make it public. Let me go ahead and change that font to there we go. Let's make this public. So I have public interface iData connection. Now remember, this is a contract. And so in this contract, I'm going to specify what methods, properties, and other items that need to be in here. So in this case, I want just one method. And I'm going to say it's going to return prize model. And it's going to be a create prize method. It's going to take in a prize model called model. So this is a contract for a method. It looks pretty similar to a method, except for the fact we don't have the public in front of it, and we don't have curly braces afterwards. We have this semicolon. And that's because in a contract, in an interface, you only ever have public items. It makes no sense to have hidden contract terms. We don't allow that. We're not sleazy. Everything's up front. Everything is visible. And so therefore, we say since everything is public, nothing is public. Nothing is marked as public because it already is public. So it looks like a method otherwise, except for the fact there's no curly braces, just a semicolon. And that's because we can't put code in here. This isn't code. This is just saying that whoever implements iData connection will have a method called create prize. The code inside their method may be radically different. It doesn't matter. All we care about is that when you call create prize and pass in a prize model, you get back a prize model. That's it. So in this case, in the form, when we create this model, and in the create prize method or event, we say, I want to save this, we're going to call something that implements iData connection and say create prize. We're going to pass in our model, but it won't have an ID populated. When the processing is done, it'll return that same data, only now it will have the ID populated because it's been saved either in the text file or in the database. So that's it. That's our interface. That's our contract. Right now, it's pretty simple because it does one thing. It saves prizes, or it creates prizes. But down the road, we're going to add to this contract as we have to do more things. But for right now, that's all we need to do. So we stop there. Now, let's move on to our static class. So again, I got to right click on Tracker Library and say Add Class. And that just selects the class up here. A static class is like a regular class when you create it. So therefore, let's call this global config. And now we're going to make this a public static class. What that means is you can't instantiate global config. It's always visible for everyone. So if you think of instantiate classes like a blueprint where you create the house off the blueprint. In this case, it's not a blueprint, it's the actual house. And everybody uses the same house, which normally means we wouldn't want to put data in there. But in this case, we actually do, because we actually want global data. So let's create a property. We'll create it as a list of data connection. We'll call it connections. Now, 2 modifications here. First, we need to make this static. So now it's a static property. Next, remember I said that anyone can mess with this. Anyone can set it and change it for the entire application. I don't really want that. So I'm going to say private set. And what this does is it says only methods inside of this global config class can change the value of connections. But everyone can read the value of connections. So how does that help me? Well, I'm going to create a public static void initialize connections. And I'll start off by asking for bool database and a bool text files. All right, so here is where I'll actually initialize the connections. Now you may say, wait, Tim, you created a list of data connection. Why is that? Well, one of the things that I said we're going to do is we have the option of saving, we may save to both a text file or text files and the database, both. And so I created this list of data connection because we could have one or more data sources to save to and pull from. So that's what this is all about. This initialize connections method is what we're going to call at the very beginning of our application to say, these are the connections I want you to set up. And in this case, I've just had it pass in, do you want a database and do you want text files? Now, right now, this is not scalable, this method. It does 2 things, a database and text files. But in the future, if you want to scale this out, it'll be very easy to change this method to do something else. Maybe to have an array of items, or just to add one more, bool MySQL database, or something like that. But for now, we're just going to have these 2. And it's okay to develop a method to do just what you need to do today. It's just a good idea to keep in mind what might come down the road tomorrow and make sure that you can still adjust if you need to down the road. You don't want to over-engineer your application to the point where it's unwieldy and yet it does one little thing, okay? But on the other end of the scale, you don't want to build your application just for today with no thought about tomorrow, because tomorrow the boss will probably come to you and say, I need it to do these extra things, and it makes your life miserable to try and redo it. So just think down the road and make sure that you're at least keeping in mind potential upgrades or changes for the future. So we have 2 booleans passed in, a database and text files. What that's going to allow us to do is say if database. Now I could say if database double equals true. And that's more explicit. And if it helps you understand how things work, this is fine. This is definitely okay. But whenever you have a Boolean value, you don't have to do a comparison because it already is a Boolean value. Whatever's inside these parens has to finally get to a true or a false value. That's why we have the equals and not equals and greater than and less than. Because if we say I is greater than 0, the result is either true or false. But in this case, this variable is already only true or false. So in this case, if database, so if we're going to use a SQL database, then do something. Let's come down here and say if text files, do something. So a couple notes here. First of all, I didn't really do anything. I left a comment that says, do something with this. And in fact, what I would do is actually make this a to-do. Okay, and a to-do list will show up in your task list. See the task list down here? If you don't have that, go to your view, and the task list is right here. Okay, but the task list, now I have two to-do lists items. Create the SQL connection, create the text connection. So right now, I don't have anything. We're going to come back to this and put something simple, but we don't have actual classes to implement yet. We don't have anything that uses this kind of contract. So now we have to think about creating it. Now I want to pause here for a minute and say this: don't give up. Some of you may be a bit lost, and that's okay. This isn't a simple tutorial. I'm not teaching you how to do Hello World. I'm teaching you how to build a real world application. And of course that may frighten you as well, because you may say, oh no, if I can't do this, then I can never be a programmer. Not true. You can do this. But here's what I recommend. If at this point you're lost, just watch the rest of this video to see how it works. Don't stress out about it, just watch it. Try and pay attention, try and follow along. But then, go back to the beginning, watch it again. This time, pause the video every time I do something and do it along with me. Knowing the end result can help you understand what's going on, and repeatedly watching will help reinforce what you're learning as you create it alongside me. Now, it also means the first time you watch this, you probably shouldn't be building it along with me unless you're really tracking. And the reason why is because sometimes typing will distract you from what I've said and you kind of miss things. So I'd recommend, if you're at all unsure the first time, don't type anything, just watch. Then go back and type a second time. All right? So that's just my aside. Don't freak out. I've done this for years. I know I can get you through this. So now we have a static class, right? Well, here. Okay. So now we have a static class that holds our connection interface. And it has a method that identifies which actual classes to put in that list, and that's this down here. Now it's time to create those two classes. Well, sort of. We're going to make those classes, but we aren't going to create the full logic yet. Instead, we're going to create placeholder code that we can get back to finishing off our form. And as long as we put that code on our to-do list as well, it's fine to do. In fact, it's really good because we've been creating some code here. We want to make sure we can get to the point where we can actually use it to make sure at least the flow works, and they can start making it actual real code. So let's create our class that will connect to our database. Right-click on Tracker Library, say Add Class, and this class we're going to call SQL Connector. Make it public. And here's the interesting thing about this one. We're actually going to say colon after the class name and say data connection. Now it's going to yell at me right away. And the reason why it yells at me is because we have not followed the contract. We said we're going to use this contract, data connection. But there is no method in here called create price. So what do we do? Well, if we select this, we can either use this drop down here or hit Control Dot. And there's this implement interface. So if we do that, and notice there's explicit interface and implement interface. Do the first one, implement interface. And what this does is it creates a new method called create price. it returns a prize model, and it takes in a prize model called model. Sound familiar? Well, this right here is this right here. So it said, okay, you got a contract here. Here's what the contract says you're going to do. Therefore, you can go ahead and create this method to do exactly that. Now, you could hand code this if you want, but it's pretty easy to just to say implement the contract. And the great thing is, as the contract changes, let's just pretend I add another contract entry here. Let's just do that. I'm going to copy this just to show you what will happen. We'll create a create prize 2. It's a horrible thing to do, but we're going to do it. We come back over here, and I did a contract connection. It's going to yell at us again. And it says, you're not following the contract. You're partly following the contract, but not the whole contract. And the way contracts work is you have to follow the whole contract. But if I do my control dot here and say implement interface, notice it only adds the extra method that I need. It doesn't touch the first method because it already has that method. It just says, what are the differences? What parts of the contract haven't you implemented? And I'll add those. So that's really nice. Let's take this back out. I'll save that. Now note, it's not yelling at me now because the contract is covered. I still have that create prize method. And I have this extra method now called create prize 2, which isn't in the contract, but yet it's in this class. And that's okay. You can have extra stuff in this class. You just have to make sure you at least have the contract stuff. So I don't really need this. I'm going to delete this. The other thing I note is this throw new not implemented exception. And this is brilliant. Microsoft has said, we create some code for you, but we don't want you to pretend like this code really works. But at the same time, we don't want to give you red squigglies. So what they said is, this method returns a prize model. They're not going to scaffold out a prize model and pretend to return it. Instead, they throw a new not implemented exception. So this code will compile. There's no red squigglies. But if I were to call this method, the first line it hits is going to throw an exception. And that exception is not implemented, meaning I haven't actually put code in here. This is a dummy method. And so that's a brilliant way for the system to have this method and yet at the same time not pretend like it's real code. But in our case, we're going to make a modification to this. We have to return a prize model, but we get a prize model in. So let's start by saying model dot. Now there's no ID yet, but we want that ID because in the database, and let's go there. In the database, if we go to the table for prizes, we see there's an ID. And you want to capture that because that's what uniquely identifies a prize. So therefore, let's go back to our model, our prize model. And up here, I'm going to say prop int ID. All right, and that's the unique identifier for the prize. So now we have a new property. So I do Control J here to bring that list back up. I see ID. So ID equals, let's just say 1 for now. That's our sample number. Then we can return model. So now this method actually does something. Now, does it go out to SQL and save things? No. It just pretends like it did. And in this case, what I would do is come here. Oops. Yes, I should put my code comments, and let's just do that. So there's my / comments, and those are great to have because it describes what your method does. That way, later on, you say, create prize, what does that do? Well, it saves a new prize to the database. But I'm also going to add up here a to-do. Make the create prize method actually saved to the database. Okay, and now I have in my task list yet another to do. Now you could say, well, but go ahead and actually do that. Make it save the database. I'm not going to do that because I'm already down a rabbit trail pretty far. Because remember, the original intent for us for this lesson was to wire up this form. And we haven't even looked at code behind this form. We've talked about it. We haven't even started there. Because first we created, our static class, and then we created our interface, and now we're creating a class. We still have one more to create. So that's a lot of stuff to do when really we're just trying to save our prize. So I'm not going to implement any more code than this. But now let's go and add the text file connector. All right, so right click on Tracker Library, add class, and we're going to say text connector for the name. And that is a class. We'll make this public. And we're going to implement, using the colon, I data connection. And again, control dot implement interface, which looks eerily familiar to our SQL connector. Now, before we go on, I also want to mention the reason why we put I in front of interfaces. And this goes back to object-oriented, because right now this is just a contract, and you can have tons of contracts on one class. In fact, if we wanted to, I could say I disposable, and then add that interface, and that just adds one more method. So now I have two contracts on this one class. This contract says you must have a dispose method. This contract says you must have a create prize method. So we can have both of those if we want. But if we want to actually inherit from a class, which means we don't just bring a contract, we actually bring code with us from a class, we can only do that once. We can only inherit from one class. And so when you're inheriting, the first item here has to be what you're inheriting from before any contracts. But in this case, if I didn't call this I data connection, how would I know if this is my class I'm inheriting from or if it's a contract? The only way I know is to mouse over this and say, oh, yep, it's an interface, which only works if you're actually in this IDE inside Visual Studio. But if you're looking at this in a text document, that doesn't work. So it just makes it a lot more clear if you have this I in front of it. Every interface will have an I in front of it. That's very clear then to know this is an interface. Now, if the class you're inheriting from starts with I, say the class name is Indiana. May not the best class name, but it starts with an I. The difference will be obvious. And the reason why, let's type it out. Now, I don't actually have a class called Indiana, but notice my casing here. The N is lowercase. This D is not. You see the difference? That's how you can tell an interface from an actual class name, even if they both start with I. And that's why casing is important. All right, that's way off the rabbit trail. I just want to make sure that you really grasp that. And again, I have a video on interfaces on my YouTube channel. But here, we're going to do kind of the same thing as what we did in SQL connector. In fact, we're just going to grab that code and do the same thing. Copy and paste. Now, saving to a text file is radically different than saving to a SQL database. But at this point, we're just doing sample. We're just saying, pretend like we actually saved it. So in that case, we don't need to worry about, differences. We're just saying, pretend like it works. And then I'll add my to-do here. So that I actually have a reminder to come back and actually do this, since this is sample code and not just that throw new not implement exception. And the reason why I did that is because I actually want to use this code just to show that it will work. Okay, so now we have both of our real classes, our full classes created. Now they're pretty simple, basic stuff, but we can come back to our global config, and here we can actually wire up our classes. So if it's a database, we're going to say we want to create a SQL connector, and let's call it SQL equals new SQL connector. And then we'll say connections dot add SQL. Now, this is going to break, and here's why. This list has not been initialized, but one of the perks of C# 6.0 is I can say equals new list of iData connection right in my property list right here. Now, if you're using a version of C# before the C# 6.0 came out, which it's really vague how Microsoft does this. It's very hard to find out what the C# version is versus the .NET version is and where they all fit. But essentially, if you're not using .NET 4.6, which I believe is Visual Studio 2015, if you're not using that, you can't do this. But never fear. If you can't do that, in your initialized connections, before you do anything else, just say connections equals new list of connection. It'll do the same thing. Okay, so you can do that if your code won't accept this. But this is a new way of doing things. So now I have created the connector and have added it to my connections list. I'm going to change my to-do here to set up the SQL connector properly, because there may be some initialization stuff that I need to do on that class that I can't do yet because I don't have any initialization stuff yet. So let's just make sure that we check that out at some point. We come back to that. And we'll come back to that in actually the next video. But for now, this works. Now I took SQL connector, that's the class type, I create an instance of that, and I added it to my connections list. But my connections list isn't a list of SQL connector. It's a list of iData connection. That's the interface. And so what this list does is it says, I'll hold anything that implements the iData connection contract, which is amazing because they don't care if it's a SQL or if it's a text file. In fact, let's do that. Text connection, text equals new text connection. Connections.add text. So now I've added my text file connection to my connections. And again, both of these are based upon if you said yes to this Boolean. If you said true to database and true to text file. So both of these can live inside of this connections list. Now, one last thing to note before we move on from this class is that I have two if statements. I didn't combine this into an if, else if. And the reason why is because in else if situation, if this was true, if database was true, we'd never add text file, even if text files was true. So you can't do this. Else if. That won't work because you'll get unexpected results. You'll only add text file if you don't have a SQL database, which if you're saying, well, I only ever want to have one connection, then yeah, that's how you do it. That's one way of doing it. But that's not what we want. We want to have the option of having one, the other, or both. In this case, it's 2 if statements. Now, the final piece to all of this is determining when to call this initialize connections. Because remember, this is when we actually set up, do we have SQL, do we have a text file? So we should do that when the application starts. Now down the road, we may say, well, I want to change how that works. But for now, we know where the application starts. Down here in program.cs, this is where our form application actually launches from, the static void main. So we have 3 lines of code that Microsoft has created. Application.enable visual styles, application.set compatible text rendering default, and application.run new tournament dashboard form. This is where we determine which form gets launched as the startup form. Now this is going to be the startup form that we use for our application when it's finally done. This is the real startup form. But I want to modify that form in just a minute to actually point to my create prize form because I want to just see that in action. I want to see it working. So we're going to change this line in a few minutes. But for now, before this line, I want to add this code. So I'm going to start by putting a comment that says initialize the database connections. And I'm going to say my class name, tracker library. And I don't think I have a reference to that. So let's right click on references, add reference. Go to projects, tracker library. Notice it says library. So I can feel free to check this box. That's my convention, but it's a way of making sure that you don't add the reference the wrong direction. You don't want to add a reference to your form in your tracker library. You want to add a reference to your library while you're in your form. So hit OK. Tracker library dot global config dot initialize connections. And now we're going to say, do you have a database and do you have a text file? I'm going to say true, true. For now, let's initialize with everything. Now that this is initialized, everybody can use that global information because it's global. So when tournament dashboard form would load, it would have access to the connection information. But I'm actually going to change this to say that I want to start up my create prize form instead because I want to see this working when I actually wire up that form. So I'm going to copy this line because this is the line that I want eventually. And instead, I'm going to add my own line that is create prize form. So now, instead of the tournament dashboard form launching, when the application runs, it will launch the create prize form. All right, in fact, we can start it now and make sure that at least it compiles and it runs. And sure enough, the create prize form started. So now we can actually get back to our create prize form and actually wire it up. Amazing, it only took us like 50 minutes to get here. But that's how coding works. You really need to think things through, make your plans, and then implement them in that order in order to safely create your code. Otherwise, you create that weird junky code that I talked about at the very beginning, that pseudocode that I created, that really doesn't work. All right, it doesn't work for scale. It doesn't work for maintaining it. It just isn't great. So again, let's come back now to our prize form. We're actually going to double click on this create prize button to launch this event. All right, so create this event called create prize button _ click. So whenever we click this button, then this code will run. Now, what do we do here? Well, here, the first thing you need to do, let's close these other items. Yes, I'll save this. I'm actually going to open that form back up. All right, so we're going to validate these 4 fields first. That's the first thing we'll do. I'm actually going to create a private method. You don't have to do this, but I like to keep my events clean. So private void, let's do a private bool. Private bool validate form. Now this validate form, we can run from anywhere. It doesn't have to be just when you click this button. So you could validate this form after this last field is filled out. And so this way, it just is on its own. We can call it from here and say, oh, you weren't valid. You returned false is not valid. Therefore, stop the process. So we return bool. So actually create a bool output equals false. Return bool. Output. So what do I do there? Well, I like to create this variable called output. And that output variable is what I'm going to return. In my case, I'm actually going to set this to be true. Now, I would love to set it to false, and then whenever I returned it, the form would be by default not valid. But it's just so much easier to say no, something is not right and set it to false than it is to say everything is right, set it to true. And I'll show you what I mean by that. So this first field right here is the place number. And this needs to be an int, meaning a whole number, and it has to be 1 or greater. All right? So we can say, let's start with this, if int dot try parse, the string is our placeholder, our text field right here. So place number. So place number value dot text. Because remember, these are text boxes, not number boxes. Therefore, this is a text value, not a number value. So we gotta do a try parse. We need to give an out int result. Okay, so this out int result will be what we change the value to a number. So we have to create an int variable here. Let's call it int place number equals 0. And then we'll say right here, out place number. Now what this does, let's actually break this down into 2 lines, just to make it a little clearer. Control X and cut that. Bool place number valid number equals our int.tryparse. So int.tryparse, what it does is it takes a string, in this case, our place number value.text, the value of this text box right here. It takes that string and it tries to make it into an int. So say that value is the number 1. Then it will try to convert that. It'll say, yep, that converts. It will put that into the place number variable. Now this is an out. What that means is we can only return 1 value from our try parse method. And so it says, I'm going to return a Boolean saying if it's worked or not. But I also want to return the value, the actual number. Therefore, I'll do an out parameter. An out parameter goes the opposite direction. Instead of passing data into this method, we're passing information out. So I have to say it's an out parameter, and I have to say a name of a variable to store the information. If that's a little confusing, don't worry. We don't use out parameters anywhere else except for try parse. And in fact, in C# 7, which is Visual Studio 2017, we actually can change this and not use out parameters and instead return what's called a tuple, which is 2 values instead of just the one return value. But we're not getting into that today. We're not going to worry about covering that yet. I want to cover what works now and will work in 2017 as well. So in this case, we're going to return back a number here, which we really don't care about. We just care about whether or not this try parse worked. Because you see, if this text would be the text ONE, which we all know that ONE translates, into 1, and that would represent a number. But when it comes to programs, they don't know that. And so they're saying it's not the actual number 1, it's a text. Therefore, this parse isn't going to work. But it's a try parse. And so a try parse doesn't crash when you get bad information. Instead, it returns a 0 here, and it says the actual method returns a false, saying, nope, it didn't work. So now I can take this Boolean value and put it right in the if statement. If place number valid number. So, but I don't really care about it being a valid number. I want to know if it's invalid. Because if it's an invalid number, I change this to be false. Now I could say bang place number valid number. And what that means is if not place number valid number, meaning if this is an invalid number, then do this. But that can be a little confusing, especially for new users. The other way you could do it would be to say double equals false. If the place number is not a valid number, then do this code. And one of the things we'll do is we'll say output equals false. Now, one trick here is do not put an else statement here. Do not say else output equals true, because this is only one of many checks. If the last check in line is valid, it would set the output to true, and then the whole form is valid. But that's not really how it works. Instead, we only set it to false if something fails. We don't ever set it to true because it's already true up here. So that's our first check. Checking to see if it's a valid number. If it's an invalid number, set the output to false. But the next check, if place number, that's the actual number that came out, is less than 1. Because remember, you can't have a place of 0 or -1 or so on and so forth. Output equals false. So if it's a valid number, but that number is -1, it's not a valid form. Now we can go on and validate the other items as well. The place name needs to have an actual name. So therefore, if place name value dot text dot length equals 0. Basically, if you have nothing in the place name value, then output equals false. Now in all of these, you could put some kind of logging statements or update the form. Maybe have an area somewhere, maybe over here or down below or something like that has all these error messages. And each time you get an output equals false, you would set an error message right here that says the place number is not a valid number, the place number is less than 1, the place name is empty. You could add those statements and then add it to some kind of form or field in your form. But in this case, I'm just going to say valid or not. All right, so in this case, we've done these first two fields, and then we have to have prize amount or prize percentage to be greater than 0. One of them does. All right, so we're going to do the same thing, but remember that the prize percentage is going to be a whole number because we're saying, okay, it's 15. If value is 15 here, that's 15%. Whereas this one here, prize amount, could be is a decimal. All right, so it's money. So we're talking about $30.15. Why? I don't know why. You'd think you'd want a whole number there, like 100, 200, 50, 10, whatever it is. But we have to allow for the fact that they might want to say, no, I want to give you $9.50, not $10. So therefore, the prize amount has to be a decimal. So let's create a spot for that. So we'll say decimal prize amount equals 0, and the other one, which is prize percentage, is a whole number. So int prize percentage. Now it could be a double if you're going to allow for 15.5%. But we're going to say no. You have to have a whole number here. We're going to say equals 0 again. And now we're going to do the same kind of thing we did up here with our conversion. So let's move this down a little bit. Let's say bool prize amount valid equals, and this is a decimal, try parse. It works the same way as the int try parse, it just converts to a decimal. And we're just going to say that the prize amount value, dot text is our string, and then out prize amount, that's our decimal that we're going to send this value to. And we'll do the same exact thing, bool prize percentage valid equals int dot try parse. We're going to say this is the, oops, not price percentage, it's prize percentage. It's prize percentage value dot text and out prize percentage. All right, so make sure you get the decimal here and the int here because that's what we're returning these values as. So that's important to get right. But now you can come here and say if prize amount equals false, oops, prize amount valid equals false, or prize percentage valid equals false. And the reason you do both is because both of these should have a number in them. They should start at 0, but one of these has to have a valid number in it. So they both have to be a valid number, meaning they both have to have at least a 0 in them. So therefore, if either one is invalid, then output equals false. But then we're going to say if prize amount is less than or equal to 0 and prize percentage is less than or equal to 0. So what this is going to do is say, we could just say if they're both equal to 0, but that doesn't capture it because what if one of them is below 0? That would trigger a this is okay. But really, they have to be both, one of them has to be above 0. So this is saying if this one is at or below 0 and this one is at or below 0, they can't both be that. So if they both are, then output equals false. All right, and now we could do some more checks since we wanted to. One of the checks we could do is if the prize percentage is between 0 and 100, because it could be 0 if we're using the prize amount, but let's just do that. If prize percentage is less than 0 or prize percentage is greater than 100. Okay, remember a percentage has to be between 0 and 100. You can't have anything above 100%. So, if the tournament brings in $1,000 and you're saying, I want to give them 150%, well, that would mean that you are going to lose $500 on this tournament. That's got to come from somewhere. So basically we're saying, no, you can't allow that. So therefore, output equals false. So that's if the prize percentage is below 0 or if it's above 100. All right, so that's our validation. That whole code right there. We'll save that. So now we're going to say if validate form. So if it's a valid form, remember this returns true or false. Oh, and one more thing I want to note here. You could, instead of having output variable and all the rest, you could just return false here, return false here. At the very bottom, return true. Some people will say that's better because it doesn't do all these other checks if the first one fails. The reason I did it this way is because that way it does all the checks. In a real application, you'd want to alert the user that they did something wrong. And here's what you did wrong. That's why I said, right here you could say that it's not a valid place number. You could put that in the form or something like that. And you do that for all the places where you say input equals false. So if you did that and you did the return false up here, you'd only check the first thing. So if this form were entirely invalid and they hit create prize, they get one message back saying, hey, change the place number. They do that, hit create prize, and get a different message back. They fix that, do that, they get another message back, and that'd be annoying. Whereas if they hit create prize and nothing is valid, they'd get all 5 or 6 messages at once. They could fix everything and then run it. So that's just a little quirk there. You may see it a little differently other places, but that's why I did it that way. Now I don't have those messages. It's just set up for those messages when I'm ready. All right, so in the prize button, click. If the form is valid, then we need to do something. Well, we need to create a model. And what model is that? The prize model. And it's right now yelling at me because it doesn't see a prize model. Well, I hit Control Dot and say use tracker library. And now it knows about it. So let's just call this model equals new prize model. And we can say model dot place name equals place name text, or I'm sorry, value dot text. Then model dot place number equals place number value dot text. And right away we have a problem because that's not valid. That's a string, but place number is an int. All right, so there's two ways you can go about fixing this. One way is we can do this try parse again. We can try parse the place number and also the prize amount and the prize percentage. That's a lot of work right in here. Or I can come to a prize model and I can come down here and I can create a constructor. Now this constructor is an empty constructor. And what it does is essentially nothing right now. It takes nothing in and it just says, do this code, whatever this is inside curly braces, which is nothing. That's cool. We actually want that because that allows us to do stuff like this. That's calling that empty constructor. Notice the no parameters. But now I want to do CTOR again, CTOR, and it creates another constructor. And it yells at me and says, you can't do that. But we can create an overloaded constructor. And that overloaded constructor says string place name, string place number, string prize amount, and string prize percentage. Now notice they're all strings, not numbers. And what this allows me to do is I can create this prize model on the fly and populate it and do all the parsing here once. And then anywhere that calls it can call this method and have this stuff parsed. So the simple one, place name, oops, capital P, it's important, equals place name. So I'm taking this parameter and putting it into this property. So that's the easy one. But now we need to do all those other parses. So int place number value equals 0. And then we're going to do int dot try parse. And we'll say the place number, that's the string being passed in, that's our string. And then out place number value, that's the string we're storing it in. And then we'll say, in fact, let's tighten this up so we'll have it all in one grouping. We're going to say place number, the actual property, place number, equals place number value. Now, I can check to see if this passed or failed. Why? Well, because I don't really care. At the end of the day, all I care about is a safe parse, meaning it doesn't blow up if you give me a string that's not a number. But if you give me an invalid string, I'm going to change place number to be 0. Because that's what the default is when it comes out of try parse if it's invalid. So I'm going to set to 0, which, guess what? That's the default for an int anyway. So I'm going to say, don't care about it. Just do it. All right? So let's do this again for our prize amount. Now, prize amount is a decimal. So decimal prize amount value equals 0. Decimal dot try parse place amount, prize amount. There we go, prize amount. And then out prize amount value. And then finally, prize amount equals prize amount value. So same thing all over again, just for the prize amount. And then finally, I have the prize percentage, which the prize percentage is actually a double. Let's go back and fix this over here. Because here we said it was an int, all right, for the prize percentage. So let's just change this to be a double. And the prize percentage here, double. All right, works the same way. It's just now we're using double instead of an int. Okay, so back over here, we're going to say double prize percentage value equals 0. Double dot try parse prize percentage. And then out prize percentage value. The thing that you'll probably forget when you're doing this at some point is to add the out. That's what I forget half the time and then wonder why it's yelling at me. So prize percentage equals prize percentage value. So now we have taken these 4 string properties or string parameters and converted them if we needed to and put them into their respective properties. We save that, we come back over here to our form, and instead of doing all of this, we can take all of this out. And notice when we do this open paren, we now have a 1 of 2. And let's just zoom in on that for a minute. So if we do this, we get one of two. That's because we either have the default constructor or this constructor. Now I left the default constructor because I want to have the ability to just say, nope, new prize model, I'll take care of populating the properties on my own. But in this case, I can pass in those 4 properties. So let's do that. Place name value.text. Next is the place number value.text. Next is the prize amount value.text. And the final one is prize percentage value.text. Notice how it scrolls off my page now. The way you can fix that is before the first parameter, you can hit enter, and then every parameter afterwards do the same thing. And now it's kind of a collapsed or a shortened version of it that makes a little more visual sense. It's easier to read. So that's up to you. So now we're creating this new prize model, and it's immediately populating with the values we need without having to do all that conversion on our side. So now we have this. What's next? Well, once we have a model, we actually have to save it. So here's how we save our model. We say for each. We can say var here if we want, or we can say the actual data connection. It's up to you. And let's just say DB for the name. We're going to say global config dot connections. And what is that? It's a list of those connections. It's a list of data connection. So for each one of those that we have, we're going to say db dot. Now look at my options. In fact, let's zoom in on those options. I have the standard equals get hash code, get type into string, but then I have one method called create prize. What does that pass in? A model, which I already have. What does it return? A new model. So what I can do with that model is I can save that if I want to, or I can just ignore it. In this case, I don't need it at this point. Maybe later I will, but for now, I don't need it. And guess what? We actually have a completed form. But are we sure it's complete? Are we sure that all that code he wrote is going to work? And I really get uncomfortable when I start writing, 50, 100, 200 lines of code without testing it. So the way to test it, we can put a breakpoint right here, the very beginning of our create prize button. Click and hit start. And that pops up our form. The very first thing I'm going to do is hit create prize. Well, it goes there. That's good. Now it's going to validate form. So let's step into, or F11. And it's going to come down to our validate form method. We can keep stepping through this. We can say the first one is try parse for our number value dot text, which is nothing. And if we step into again, we can expect this now and see that the place number value is invalid, it's false. Therefore, we're going to return output false. The place number is 0, so it's less than 1, it's false. The place name value dot text dot length is 0, therefore output is false. And we can keep going if you want to, but I'll just put a breakpoint down here and say continue to that point, hitting the green button, and then I'll step again and come back here, and it just exits out. That's all it does. So we'd probably want to add some kind of message there that says, hey, it's an invalid form. Let's actually do that, just a real quick one. Hit stop right now. Just a real quick one. So Let's take our breakpoints out. And this time we're going to say, if it's not a valid form, else, and let's just do a very simple message box dot show this form has invalid information. Please check it and try again. And we could make that a little more fancy with the buttons we have and all the rest, but let's just do just that. If we launch this again, I'll move it back over to where it was. I hit create prize, and nope, it's invalid. Okay. We can come back over here though and put our breakpoint inside of the valid form. Now let's go back and put a place number, first place. The amount, the prize amount is $50. That's going to be 0 for prize percentage. Remember that 0 is the one we ignore, but you have to have a number there. We create prize, and hey, it's valid because it got to this line right here. Let's step into this, and notice it comes down to this constructor. We can say, all right, check that out. Place name is first place. That's good. We can do a try parse, and that seems to work because place number is 1. The prize amount is 50. That's good. And the prize percentage is 0. Great. And in fact, if we step to the next line, we can mouse over our model and see that all of that information has been entered. The ID is still 0. So now for each iDataConnection DB in global config.connections, let's go into this. First, you can mouse over this and see that there's 2 connections, the text connection and the SQL connection. So that's great. We actually have something. So for the first one, which if we mouse over DB, it's the SQL connector. We're going to create that prize model. We're passing in our model. When it comes right to our SQL connector, and notice we're modifying the ID to be 1 now, and returning that model. Now we're not doing anything to that model, but at least we know that it actually pretended like it went to the database and saved it. Now we're looping through the next one, and that's our text connection. And again, we run this, and it goes to the text connection class, and it calls the create prize to actually save this model. Now it's not actually doing anything, but that's okay. And we're done. So we hit continue. This form is now working. Now there's a couple of tweaks you want to make to it before we're done. One tweak is when you're all done creating a valid form, you actually create it, then go ahead and wipe out these values. The other thing I want to do is I want to add that these 2 fields start off with a value of 0. That way you don't have to add 0 to the other field. So that last one's easy. We'll go to our properties for that text file or a text box. And for the text, we'll put 0. And down here, the text, we're going to put 0. And that's it. That's our properties are now set. The other one is to clear out that form. Well, if it's a valid form, we don't want to clear it out if it's invalid form. We're going to say these 4 values. And let's just grab these and actually copy them. And paste them down here. We got to take the commas out. And it's going to yell at us for a bit. And that's okay. We can move them back. We can say equals empty string and a semicolon. We can do that there. These last 2, we don't really want to say empty string. We want to say that it's a string with 0 in it, the prize amount and the prize percentage, because again, the default value for prize amount and prize percentage is 0. Now if we run this, and we won't put a breakpoint this time, so let's make sure that's cleared, and it is. So now we can say it's second place. The prize percentage is, let's leave them both 0 for a minute. Oh, it's invalid. Okay, prize percentage is -15. Nope, still invalid. Oh, it's +15. Yep, that worked and it cleared our form. All right. So that's a lot of work, but at the same time, now we're done. Now we've got this form created and we've got a pattern for how to save to a database, a text file or text files, or both. Okay, so that's all taken care of for us. So that's great. Now we need to move on to actually wiring up those classes. So we have the SQL connector class, and we have SQL connector class and the text connection class. We need to wire those up to actually do the work. So in our next video, we're going to start off by doing our SQL connector and actually talking to our SQL database. So don't forget to stay tuned for that. Welcome to Lesson 10 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to look at connecting to our SQL database. In the last video, we built the prize form, but we only wired up to the class that pretended to talk to SQL. Now we're going to actually take out that sample code and put real code in place to talk to SQL. So let's jump right in. Here we have our solution, our two projects, and just by way of review, down here in the Tracker UI, which is our user interface, in the program.cs, we made a couple of modifications. The first thing we did was we added this line right here. And what this does is it wires up which database or databases we're going to talk to. So in this case, we're connecting to both SQL and the text file. And then next, we change the application run from the tournament dashboard form, which is going to be our final form, the actual real form. We change it to our prize or create prize form so we can kind of test things out and make sure things work. So those are a couple of the important changes we made to the program.cs, which is where our application will start, since Tracker UI is the bolded of the two projects, which means it's the startup project. So before we jump in today, I want to make a couple of modifications to our library though. The first modification is I want to clean things up a bit. So I'm going to right click on my library and say add new folder. And I call this folder models. And then I'm going to drag anything that says models at the end into this folder. Just click and drag. And there we go. So there's a folder filled with models, and that just helps kind of keep things clean, because now I can do this, and all of a sudden, instead of having 8 or 10 CS files in this one list, all the same level, we can now kind of break these out by level. Now that didn't change anything on how those models work. The folder structure really doesn't matter, except, and here's the one exception, if I were to add a new item now. So if I right click and say add new class, and let's just leave this as class 1 since we're going to delete it. I want to show you the one change that happens. So let's look at team model for a minute. Team model, the namespace is tracker library. If we go to class 1, the namespace is tracker library.models. And that's because by default what happens is that when you're inside a folder and you add something new, it takes the path of the namespace, it takes from the project name and then any path down to it. So if I had models and then in here a folder called people, it would say tracker library.models.people. So that's just something to note. Now when you drag a model or a class in here when it was not created here, it will not add that into the namespace, because adding that namespace would break our application, because we are pointing to the root of this for all of these models if we are using them. Most of them we aren't using yet. But that means you have a choice to make. You can either change the namespace on all of these to match this tracker library.models, or you can leave it off. If you leave it off, then you'll have to, anytime you add a new one, just take it off as well. And that's really up to you. It's whether you want to have that separate out or not. I kind of do. And the reason why is because that way it differentiates this is a model versus this is a class that does something. Okay, a model just, essentially a model holds data. And so we call it a model just to differentiate it from the stuff that does work, like global config. Global config does work. It does hold information, which, remember, that's the use case is not normal to be a static class and have static property here. But it does hold information, but really it's doing work. That's its primary job. Whereas the person model, its only real job is to hold information about one specific person. So in this case, I'm going to take this namespace right here, and I'm going to actually add it to all of my other models. And you notice for a minute that I had red squigglies, and that's because they were referring to other models and the namespace had changed. Now, whatever namespace you're currently in, you don't have to have a using statement for that namespace. So we don't need a namespace or a using statement for the namespace tracker library.models because we're currently in that namespace. But if I were in the namespace tracker library, then I would need to add that using statement in order to bring in these models without putting the path models dot team model. See, if I put models dot, it's happy now because it knows what the namespace is, because again, the beginning is actually assumed. The beginning would be the tracker library. So that's the full path. But this is assumed because we are in the tracker library namespace. So now we can take that off, and we'll actually take that off as well. And we're now in the models library. All right, we can delete that class one. That was just an example. Okay, so there we go. We've got our models inside a model folder. And now I'm going to do a little more cleanup. I'm going to do another folder. I'm going to call this folder data access. And these names aren't necessarily really important. It's just for me to know what this is for. And so in this case, I'm going to move, and here's the debate, global config. Do I move that into data access? I say no, because it's not really about data access, it's about configuration. And so I'm going to leave it alone, but I will move the iData connection, the SQL connector, and the text connection. And that also brings up another issue, which is this is named differently than this. We have SQL connector and text connection. So I'm actually going to rename text connection to text connector. So let's rename this to text connector. And it's going to say, would you like to also rename the project and all its references to text connection? So what it does, it says over here, oop, it was named text connection. Let's change it to text connector, which is why I renamed it over here in the file name first, because that renamed the class name. It does not go the other direction. So therefore, if you need to do a rename it over here, and then it will fix this if you say yes to that dialog box. Now I've got a dialog yelling at me saying, hey, I don't know what prize model is. That's because we don't have a using statement for tracker library.models. So if I do my control dot, using tracker library.models, that puts it right there. And now life is good again. And now this iData connector or connection is yelling at me because it's saying I am not implementing properly the create prize interface. And it's actually not really true, but what happens is we come over here to our our interface, it says, I don't know what prize model is. But if I say using tracker library.models, and I save that and I come back, this should be good now. And it is. And SQL connector, we're going to do the same thing. We're going to do the control dot, add the using statement so we can change this so it works. And we'll save that. In fact, we'll save all. This little two save icons together is a save all, which means it saves all of my files here, which is nice. So now I can move these files, the I data connection, I'm going to drag in a data access, the SQL connector, and the text connector. And now we can actually change that namespace if we like, which I do. .data access. Now, how do I know that's the new namespace it should be? Well, that's because this is the name of the folder, and it is case sensitive. So it's going to yell at me for a bit. No worries. We're going to change our namespaces here. That should solve that problem. Then global config. It's referencing the I data connection, so I need to change to add the using statement for using tracker library.data access. And that solves the world's problems. So now I've kind of cleaned up my tracker library. It's a little more logical. Now I have my data access folder, I have my models folder, and then I just have global config right in the root. The last thing I want to do is actually do a build solution, because I'm assuming there's going to be other issues that I've missed. In fact, right there, I got a red squiggly. The build failed, it said. It's got 3 errors. So if I come here and say view code, it says I data connection, prize model. I don't know what these things are. So if I hit control dot, add the using statement. And then down here again, control dot, add the using statement. Now see, there's 2 different using statements because one is for .data access, one's for .models. But with that being said, now if I build the solution, everything works. If you see in the lower left-hand corner, build succeeded. So now we can actually get to writing that data access code. And that's a lot of extra work before we actually got to our quote-unquote real work. But I want this project to be as close to real world as possible. And this is real world. You know, real world is you come back to a project and go, oh man, I was coding late at night and made some mistakes, like calling one connector and one connection. Is it a big deal? Not really, but at the same time, having that consistency of calling the same thing the same way every time really helps you when you're looking for a new thing. You know, so if we were going to look for a new data connector and it said data connection instead of data connector, we'd be a little confused. Is that really the same thing, or is that something different? And so by naming it connector every time, then I know that, yes, this is the same thing because it fits the same pattern. So that's just something to keep in mind. And again, cleanup, that's not something you should let wait until the end of the project, just like documentation isn't. These are things you should be doing as you go, because it's fresh in your mind now, and it's also much easier to change. You saw the number of tweaks I had to do to change those namespaces, and they were just for one form. I had those namespace changes to do. So if I had all of my forms wired up, even this small project, it would still be a much more significant change. I have to do a number of changes. And so the earlier you can do these changes, the better. And just make sure when you come back to a project that you look it over and make sure things are clean in the way you want them. All right, so on to the actual work of today. So let's right click on this tab and say close all documents. I just want to close everything out. I know the document I want was open, but it's just easier to clear everything else out and start again opening things up. So in the SQL connector, we have this to do right here, or we could have gone to our task list and looked for that to do which is right here. And double click it, it would take us to it. In fact, let's close it down, double click this, and there you go. Just to show you that that's a quick way to navigate your project. It's also a quick way to remind yourself of what I need to do yet in order to get this project to work. Because notice there's actually 3 there. There's one for wiring up the text files and then set up the SQL connector properly. So in that one right there says, yep, that's not right. So let's go back here and start planning out how we're going to wire this up. And this is important to get right because we're going to do this over and over and over again for all of our different forms. So let's think this through a minute and start planning out how we're going to do it. Now we're going to use Dapper as our connection ORM. And an ORM is just a tool that helps you connect to a data source like SQL in an easier manner. It helps kind of take away some of the complexities of connecting to a SQL server. So I love Dapper because it's practically as fast as doing it with just straight C#. I used to do just ADO.NET, which is a little more complicated, especially when you start getting into the data sets and data tables and converting a data table to a list of model and all that went into it. Whereas now with Dapper, it kind of just does it for us and it takes us straight to our list of model. And yet it's almost as fast as the way I was doing it, which was the fastest way you can do it. We could use other tools like Entity Framework, but Entity Framework can be quite a bit slower to the point where it's 10 times slower than even Dapper. And so I don't like to use Entity Framework. It's also much more complex. And you can find out all my views about Entity Framework in my YouTube video on connecting to SQL from C#. But to start with, let's add a reference, manage NuGet packages. We're going to add a reference to Dapper. So go to Browse and just start typing Dapper. Hit Enter. This first one right here. We'll install the latest stable version. Just click Install, wait for it to be done. All right, there we go. So now it's installed. We can close out of this. And so now we can see in the references, we have Dapper right here. So now how we're going to use Dapper? Well, the first thing you need to do is we need to use Dapper with a connection string. If you've watched my YouTube video, I just mentioned the C# SQL connection. We have to have in our app.config a connection string. That's the best way to do it. That way we can change it even while the application is running. It's not hard code in our code. And it also allows it to do some other things with it as well. But in the app.config, notice the app.config is not in our library. It would seem to make sense it'd be in our library because this is where we're going to actually do all of our work with Dapper. The UI doesn't know anything about Dapper. It just knows I call this method right here, I pass in a prize model, I get back a prize model. That's all it cares about. In here is where we're going to do Dapper. But this is just a DLL. The DLL doesn't actually have a user interface, and it also does not have a .config file, whether it's a web.config or an app.config. And so instead it uses the config file from the user interface, which means that the connection string actually goes in this tracker UI app.config file. And so here is where we'll put our connection string. To do that, under configuration, we're going to do our less than sign to open up a new section and type connection strings. Close that out. And inside here, we're going to add our new connection string. So we're going to say add name equals, and this is any name you want to give it. I typically give it the name of my database. Oops. So I call this tournaments. And then I'm going to say connection string equals, and inside here I have to first give it my server. In my case, it's ./SQL 2016. And a semicolon database. That's tournaments. Trusted underscore connection equals true. What that trusted connection is, it's saying use my Windows credentials in order to connect to the database. And that's usually the best way of doing things, is having that trusted connection, because then no one can come in here and read my username and password to SQL. Now, if they have access to your application, they have access to SQL at that same level. So if they were to quote unquote steal that username and password, if you had one in here, it shouldn't give them any more access than they'd already have. So if you find yourself having an issue where you have people connecting to SQL Server that you don't want to give many rights to, you really need to lock things down the SQL side. And there's ways of doing that. I talk about a little bit in my SQL course on imtimcorey.com, but really the best way of doing things that I know of is to, if you have to use a username and password here, to make sure that username and password only has access to execute stored procedures. That's it. They don't have access to connect to the database, to read the table structure, to write to the tables, or anything else. They just have access to stored procedures. That way, the permissions they have, if they were to take those credentials, are the exact same as if they were going to use this application, which is what you want. So that's the connection string. If you go to, again, if you watch my video, I cover much more depth connecting to SQL. But if you go to connectionstrings.com, I believe, just Google connection strings. They'll show you all the different connection strings for SQL and all the rest that you can connect to. And finally, provider name equals system.data.SQL client. And that's just saying use a SQL connection or SQL client for connecting to this database. All right, so that's our connection string. Why is a connection string important? Well, this string right here tells Dapper how to get to SQL Server and then how to get in. So it says, here's the path of SQL Server. Here's the database you're going to start in. Now you can go to any database with this with these credentials if you have permission. But this is the default one. And what that means is it's kind of like a namespace where if you're in the tournaments database, you don't have to specify, I want something from the tournaments database. So it just makes life a little bit easier. And then finally, the trusted connection just says, these are the permissions I have. So location of the SQL Server, default database, and what permissions there are. So Dapper needs that in order to talk to SQL Server. And we can have as many as you want as far as connection strings in this list. So you just do an add down below this line and add another one. Also note that this string right here can be transformed with a config transform. So on build, if I do a debug build, I could transform it to something else. If I do a release build, I could transform it to something different. So for example, at my company, we have multiple transforms, one for the development server, one for the staging server, one for the production server, and then a couple other miscellaneous ones. And we're not going to get into transforms today. We're just going to leave it as it is and call it good. That'll be for a different video. We don't want to make this too long. So back over here, we now have a connection string in place, and we call it tournaments. So we can rely on that, but how do we even get our connection string? Well, I can go over to the global configs file. I'm actually going to add a new entry here, a new public static void. Let's just kind of, well, we can't really scroll up here yet. There we go. All right, public static, and it's not a void, it's going to be a string. Public static string, and we'll call this CNN value, and that's connection value, or connection string, let's call it that. And then we'll pass in a name of the connection string we want to get. All right. And let's just call that name. All right. So what that's going to do is it's going to go to the app.config and get me the connection string by looking up this name. And it's going to look up this name and then return for me the value inside of this string. So this right here. So I give it this, it gives me this. And this is pretty simple. The code is configuration manager dot connection strings, oops, square brackets, name dot connection string. And we'll return all of that. Now it's yelling at me because we don't have access to this namespace. And in fact, if you do it, the control dot, there's not a add using statement for that. And that's because we have to right click on references and say add reference, come to assemblies, click in the search box here and start typing configuration. And usually don't get past config. You can see here config, configure, and configure is as far as I got in a couple different attempts. So here we have system.configuration, not the .install version. The one is just system.configuration. Check that box, hit OK. It's going to add a new reference here to system.configuration. And it's still yelling at us, but now if I do the control dot, or do this little drop down by the little light bulb here, we have the using system.configuration. And now life is good. Now, whenever anyone calls globalconfig.cnn string and passes in tournaments for the name, they'll get back this string right here. So that's perfect. Now back here again. So I've done a couple of setup things. Now I need to actually put some kind of code in here that does something. So let's get rid of our sample code. I'm going to add a using statement. Using, and then the open parens, IDB connection. And that's not in the using statement list, therefore I do control dot using system.data and say connection equals new system.data.SQL client .SQL connection, and I can say global config dot CNN string, and then quotes into the parens, I'm going to say tournaments. Now that's a lot for one line, but that's okay. So now what this is I've said I want to create a new IDB connection. Now notice the I in the front, which we've now realized means an interface. An interface means we can have any hard code behind it, meaning we can have, in our case, we have our SQL connector or we have our text connector. They both are an iData connection. But this IDB connection is something that Microsoft set up. And in this case, we are going to fill this connection with a system.data.SQL client connection. And we're going to put that in there. So we could put a MySQL connection in here, or a text connection in here, or a number of other different databases, or anything that fits the IDB connection interface we could put into this connection. In our case, we're connecting to SQL. So that's this code right here. And again, if you watched my C# to SQL database video, you'll be kind of familiar with this. And I say basically just keep a copy of this basic structure on hand and just copy and paste it, because that's, you don't have to memorize stuff in programming. It's probably not the best use of your brain power trying to memorize things. It's good to know the basics and good to know a good bit. But the reality is you can keep this in a file somewhere and just keep using the same structure. As long as you know why you're doing it, it's not a problem. Now the using statement here is interesting because what it does is it says, I want to wrap this right here and say that when you hit this curly brace right here, this connection gets destroyed and destroyed properly. And so that way, this prevents against memory leaks. So it used to be that if your application, had an exception or did something weird when you were trying to connect to a database, you could accidentally leave a connection open. And if you do this long enough, then you have lots of connections open. And your SQL Server gets slower and slower, and your application gets slower and slower. And you're wondering, what's going on? My computer's bogging down, my application memory usage is going through the roof, and all this other stuff. And it's because of memory leaks, because you had crashes and other unexpected circumstances that prematurely got you out of code but didn't close the connection to the database properly. This using statement fixes that. What it says is, it doesn't matter what happens. When you hit the end of this curly brace, whether it's through exception, through anything else, when you hit the end, we're closing it down. And so that's just a real safe way to connect your database in such a way that you don't leave connections open. What that does mean, though, is I'm not going to open a connection at this root level of the class and then reuse it over and over for different methods. I'm going to open this connection every single time. So now we have our connection to the database, but what do we do with that connection? We haven't really decided how this data goes in the database. So let's go over the database itself. We have the prize table, and we could, if we wanted to, write a query that said something like insert into dbo.prizes, and then put values, and then basically take that query and just paste it into code here and call it. But that's not really what I'd like you to do. Instead, what we're going to do is create a store procedure. Now we have already created some store procedures. We have the gets, get by tournament, for prizes, for team, and all the rest. But instead, we're going to create a new store procedure. We'll delete this. Now we could keep this here, but I'm just going to delete all of this and start right from the create procedure. I would encourage you to put the comments up above that says who created it, when it's created, what it was for. That's really helpful down the road. It's especially helpful if you put a changes section in there where every time you change the store procedure, you put a note as to what you did and when. Because that way you can see the history of the store procedure as well. So the name of this create procedure is DBO. We always start with DBO, unless we have a different namespace essentially in SQL. All right, so DBO dot, I'm going to start with SP prizes because this is on the prizes table. And we have this convention of starting with the name of the table. And now you know what parameters to pass in. And this is where it's beneficial to have two screens because you can put your prizes table on one screen and your store procedure on a different screen or something like that. What I'm going to do is actually expand out prizes and go to columns. So now I know which columns I have in my prizes table. Because that's the columns I'm going to pass in. So I'm going to pass in 4 values. The first one is at place number. Now when you pass in a variable, you start with an at symbol. Okay, so this is a variable called place number. And it's a type int. And then at place name, and it's a type nvarchar 50. And that's really helpful right down here, I can see nvarchar 50, so I can match that up here. That way I know that I'm not allowing more data to come in than can be stored in this table. At prize amount, and that's a type money, and at prize percentage, that's a type float, if I can spell it right. All right, so let's get rid of the comments here. Set no count on, what it does is it says, let's not pass back how many records you actually modified. And that's fine. So I'm going to say insert into dbo.prizes, and then I give it the 4 columns I want to put the values into: place number, place name, prize amount, and prize percentage. Notice I don't insert the ID because the ID is going to be auto incremented. I can't write in that field, or I shouldn't write into that field. There is a way to write into that field, but it's unsafe unless you know exactly what you're doing. So instead I'd say insert into the prizes table. Here's the 4 columns I'm going to write into. And then for the values, I'm going to say at place number, at place name, at prize amount, and at, comma, at prize percentage. I semicolon at the end. So there's my insert statement. Now, the one thing I'll go back to my code real quick and show you, let's pop back there, is that we return a prize model. It says return the prize information, including the unique identifier. So if I call this store procedure as it is right now, it would create a record in the prizes table, but I wouldn't know who is, what the ID is of the person who was inserted in this prize table, or what the prize was. So I wouldn't know the ID of the prize inserted into that table. To fix that, what I can do is I can say at ID int output. And I can actually say int equals 0 and output. And so what that's going to do is I'm saying the ID, you don't have to pass a value in, because if you don't, I'll just say the value is 0. Because I really don't care if the value is coming in. We're not going to use that to write to the prizes table. But I did say at the end of it, output. What that means is this value will be sent back to the person calling this store procedure, which is how I'm going to take the ID and send it back. But how do I get that ID? Well, I say select at ID equals scope identity. And I'm done. So what this scope identity is going to do is say in the current scope, which means that in our case, just this store procedure call. Okay, so there is an idea of scope in store procedures, or in SQL, where you can say, I'm going to call these 3 store procedures in the same scope. And that'd be really helpful for bank transactions, where we could say, I want to take money out of a checking account and then in another call, put it into a savings account. We wouldn't want those 2 actions to be separated, because if you took money out of my checking account and then crashed, that money would go away. It'd be out of my checking account, but it wouldn't have gone into my savings account. And so we can link those together in what's called a transaction. So in that transaction, that would be the scope. But in this case, we're not saying specifically that I want a transaction. Instead, what happens is this call becomes its own little transaction. So in this transaction, I want to get the identity. And what that is, the last identity written to a table. And so in this case, we only did one identity insert, and that's in the prizes table. So we said insert a new record, which would have created a new ID for that record. That ID is the last identity created. Therefore, when I ask for it, the last identity created, it's going to put the value of whatever's here into this variable. And since this variable is an output variable, I can then capture that on the other end. So I'm going to say execute, which is not going to run this store procedure, but instead create it. Now, don't do what I just did and have something highlighted and say execute, because you're going to get this error right here. This error says incorrect syntax near create. And you say, but that syntax looks right. Well, that's because I highlighted just this section. Remember that in SQL, wherever you highlight, that's the code that gets run, and that's it. So what I would do is either highlight the whole thing, or if this is the only thing in this file, then you can just highlight nothing and execute. I love the idea of highlighting just what you want, because that way, if you're in that habit, later when you have two statements in a file, you'll be more likely to protect yourself by highlighting just the statement you want versus being used to just hitting run on any blank file. I'm going to run this, and it says command completed successfully. And if I come down here, my store procedures, and I right click and say refresh, we will now see that I named this improperly. I named it SP prizes, but nothing else. Oops, no worries. We'll do this, SP prizes underscore insert. We'll run it again. And now if we refresh this, we see that we have the prizes, the wrong one, prizes get by tournament ID, and prizes insert. So how do we get rid of SP prizes? Well, I could right click and say delete. That works. I could also wipe this out and instead say something like drop procedure dbo.sp prizes. And it's not a list because IntelliSense has not updated for this window yet. So if I hit Control-Shift-R and wait for a minute, it will update, and then it will know that that's actually the correct file. And if we run this, it's completed successfully. And if I right click and say refresh on store procedures, the incorrect SP prizes goes away and life is good again. So the issue with programming is not that you don't make mistakes. We all make mistakes. The issue is knowing how to correct your mistakes and then also working at putting things in place to not repeat your mistakes. All right, so we have a store procedure. The store procedure's name is SP prizes underscore insert. And in fact, let's call that up. So I'm going to modify that. Notice the modification, when I right click and say modify, it brings it back up, but it has alter procedure instead of create procedure. And that's the syntax to modify a store procedure. So I'll keep that up, but we'll refer to that in a minute. Let's go back to our code. Okay, so we have our store procedure. We know how to at least put the information in if we were in SQL. So how do we do it in code? We're going to start off by saying var p equals new dynamic, if I can spell, dynamic parameters. I do a control dot on that and say using Dapper. This is a Dapper thing. So dynamic parameters, and we're just going to use var because it's a little simpler with something like this. But in here we can say p.add. And this is where it's a little trickier than the way we did it in our C# to SQL Server or SQL Databases video. But once you kind of see it once, I think you'll get the hang of it. So the first thing we need to do is add our variables. So and what are the variables we have? Let's do this. I'm going to copy these. I'm just going to Shift Tab once and copy these. And come up here. Let's do it up here. Paste them in, and I will then comment them out. So that just gives me my variables and what types they are. So I have them. So at place number is the variable name. And then the value is model.placeNumber. And that's it for that parameter. So what we're doing is we're creating a list of these parameters, and we're adding them all to P. So P.add, and we'll say this one is model.placeName. And let's actually copy this place name and paste it here. P.add at prize amount, and that's model.prize amount, and then P.add prize percentage, model.prize percentage. Notice I tried the copy pasting thing from up here. It was just too distracting. When you're typing these out over and over again, trying to do it the same way every time, sometimes it's more distracting to try and copy something and paste it than it is to type it in, and if you have to, later come back and copy and paste to make sure you got it right. So P.add, and this is the interesting one, ID, because this is the one that goes the wrong direction. It comes out, doesn't go in. So I'm going to pass a value in of 0. I'm going to say a db type, db type, colon. Notice it's trying to do the IntelliSense was trying to say, I think you mean db type, the capital D in the front, and that's not what I mean. Instead, what I'm doing is I'm saying we have optional items here. Notice a db type question mark and the parameter direction question mark. By saying db type colon, that's saying, yep, this is this parameter right here. Whatever's after the colon, that's its value. So that way you can actually mix up the order if you wanted to, or when you have lots of these optional items, and there's even more with this right here, like with scale and precision and size and all the rest. When you have lots of these optional items, you can specify which ones you want to fill in and leave the rest blank. So db type colon, and the type here is db type dot, and here's the types we have. In this case, we want int 32, and that's the standard lowercase int. So that's what we want. So int 32, comma, direction, colon, and then notice when I hit space, it immediately opens up IntelliSense and goes right to parameter direction, because that's what it's expecting, a parameter direction. So if I hit tab, now I can hit dot, and I can say this is an output variable. So this parameter direction is an enum. Notice when you mouse over it, it says right there enum. So it enumerates the options we have available to us. In this case, we have a few. We have the standard input. We have input output, which goes both directions. We have output and we have return value. In my case, I'm using just an output, but if I wanted to, I could also pass information in on this ID value, in which case I could say input output. To change that in SQL, there's no change to make. As long as it's an output variable, I can use it as either an output variable in C# or an input output variable. And like I said, by default, they're input, therefore we don't need to specify because that's what it assumes. So output it is. So there's all of our variables and their values. Now I can say connection dot execute. And this is going to actually run some kind of store procedure, and it's assuming that nothing is going to come back as far as a data set goes. So what it's assuming is that we're not going to say, give me all of the prizes and return back a number of rows in a table. That would be a query instead of an execute. But with execute, it's saying you're just going to call something, probably an insert, an update, or delete, and not really pass information back. So we want to do an execute, and then we're going to say, in double quotes, dbo dot sp prize. I'm going to double check to make sure this is right. It's sp prizes underscore insert. So prizes underscore insert. Always make sure you get that right, because otherwise, the first time you run through this, it will error. All right, the next parameter is our parameters. In this case, p. And then next, the command type, or I'd say command type. It's right down here, colon. Notice I'm skipping over a lot of these. I'm skipping over IDB transaction and the command timeout to go right to command type. And the command type is command type dot store procedure. Again, that's a enum, so it popped it up in the IntelliSense. I just hit tab, I hit dot, and it pulls up my options here, which are, looks like 3. Store procedure, table direct, and text. We want the store procedure option. All right, and that's all there is to it. Now, this code, and that's all there is, this code is going to execute this store procedure, pass in all of this information, and then it's going to get back information, but we haven't actually captured where this comes into. So let's do that. So I'm going to say, let's take the model itself. Let's just modify this. So model.id equals p, that's our dynamic parameters, p dot get. We have to do a less than, greater than signs because it's a get of t. What that means is that it's generic, meaning you can get any different type you want. You just need to specify the type inside of these angle brackets. So in this case, the type is an int, and then we put in quotes inside parens at ID. And what this will do is it will look at this dynamic parameters list called P. It's going to find this particular parameter by using this, and it's going to say, give me the value of this, and oh, by the way, it's of type int. Therefore, we can put it directly into my ID because my ID is also of type int. Quite a coincidence, right? Of course not. We planned it that way. All right. So finally, I return model. And now life is good. Or at least it's mostly good. Now, there's one thing we haven't really covered here yet, and we're not going to in this lesson. But that's the idea of what happens if things go wrong. And as a developer, you need to think that through. For example, what if this tournaments didn't exist? This that app.config entry. What if it's actually tournament? Well, that'd probably blow up in some way. How is it going to blow up? We don't want to just crash the application. We want it to actually show a message, possibly, or maybe we do want to crash the application. One of the things that programmers, when they first start working with error handling, one of the things they tend to do is say, well, I could wrap this entire thing in one big try catch. And then if I do that, then things are safe because I can give a message saying, hey, something didn't work. The problem with that is you can also leave your application in an uncertain state, meaning maybe this is one of 3 tasks that need to be done, and it actually broke on task number 2 of 3. Well, that means that it got half done and then the other half isn't done. How does your application recover from that? If you haven't planned a way to recover from that, it can actually be worse to have your application continue to run, because your user will continue to do more and more things to compound that error. And so sometimes the best thing to do is actually crash your application. Now, we're not going to say, okay, the solution then is just have no error checking. That's not the case. But I'm just saying that error checking is more than just saying wrap everything in a try catch. So we're actually going to have a lesson entirely dedicated to tracking and catching errors. And so we'll do that later on. But for now, we're going to leave this as it is and assume that things go well or everything will crash. So let's actually see if this works. And really, I don't have to do anything else to try it because we've already wired up. Remember, the create prize form is already wired up to both a text file, a text connector, and also a SQL connector, which would be this one right here. And it already calls this create prize method. We can see that in the code behind, where we have this loop, and it's right. Validate form. Oh, here we go. It's too simple. There's the loop. So for each iDataConnectorDB in globalconfig.connections, and we said both SQL and text connector, I want you to call the create prize method, and here is the model, which just happens to be whatever you filled in here on our form. So it's already gets called. So let's run this and see if it actually works. Now, before we do anything with it, here's the form. Before we do anything, I'm going to go to close that out and go to my database and do a new query and say select star from dbo.prizes. And I have no prizes in my prize table. You can see that right down here. So now let's fill in information. I'm going to say the prize number is, or place number is 1. First place. The prize amount is, let's be generous, $100. And we're going to leave the percentage alone because it's an or here. We're going to say create prize. And wait for it, cleared it out. So something happened. We come over here to SQL and say execute again. Check that out. First time's a charm. Place number is 1. Place name is first place. Prize amount is 100. And prize percentage is 0. Now let's test it again. And this time we're going to say to second place. We're going to leave prize amount blank, but instead we'll do something like 50%. Create prize, it goes blank. That's quicker that time. And if we execute this, we now see that we have a percentage of 50. So it's good to test these things out both ways just to make sure that things are working. And the other key thing here is to make sure that things are going in the correct fields. I've had that happen before where I'm putting stuff in the wrong fields. And so I try and, you find a 2 over here and a 1 over here. And you find these are empty or null or something like that because I try to put first place, a string, into a number field, and that just doesn't work. And you'll go, oh, I swapped those 2 around. You go in the code and fix it. So it's just a matter of making sure that all the data goes in and it goes in the right spots. And I tested both the prize amount and the prize percentage to make sure that I indeed had both working the way I wanted them to. All right, I'm going to zoom out here. I'm going to minimize this and close this out. The one thing, and this is one of those things where this application is being built as if it were real world. And so I've left a couple of things in here that were frustrations that I found during the design process. But I'm like, you know what? No, I'm going to leave that in there and we're going to work through it live, essentially. Because I don't want to hide from you all the struggles that go on with the design process. Now, there's some things in here, I'm not trying to act like I know everything, okay? There's some things in here that'll pop up that I'm like, I didn't even think about that. But in this case, this issue is one that I came across in the design process and went, I wish that could be different. But that's the idea of having both the SQL connector and the text connector writing together, meaning they're both working. The issue with that is this ID right here. Now, if I write to SQL, I may get an ID of 25. But when I write to my text file may have less records in it. So I may get an ID of 15. When I go to use this value somewhere else, I can't have two different IDs to identify this one record. That's going to cause some confusion. Now, I could wire up my SQL connector to be the primary one, and then it's going to fall back to or have a copy written to the text file, in which case whatever ID SQL has will then take that and write it to the text file. That kind of works, but it kind of defeats the purpose of having that just drop in whichever one you want to do kind of database. So I'm not going to do that. Instead, what I'm going to say is, instead of having as many different connectors as you want running at the same time, we're going to back it down to you can only have one connector running at a time, but you can swap it out at any time very easily by saying, okay, now I want to work with just text files versus tomorrow I'm going to turn on the database instead. It'll be different data, but at the same time, you won't have that stepping on toes with the IDs. So with that being said, we have to kind of rework some code. And now's a great time to rework code before we get too far down the road. And really, in my design process, it was when I was wiring up the SQL connector that I went, oops. And so that caused that thought process to go on. And the worst thing you can do as a developer is freak out and say, oh no, I messed everything up, and destroy everything and start changing everything at once. Take a step back, breathe. The world is not going to end, and it's not going to be solved by you just writing more code real quick. That's not the solution. The solution instead is to plan. Planning causes so much less hassle in the long term. Because even though I planned this application and I started to write code and ran into an issue I didn't plan for, my solution for that is to actually plan for it, even though I have code written. And that does mean a little bit of rework here, but not much. So the first place I want to rework is where we have the global config. I want to change a couple things. First of all, we're not going to have a list of iData connection. We're going to have a iData connection. That's it. And so when we initialize the connections, we're going to say if it's database, then the connection equals SQL. And then here, what we'll do is we will say else if. Remember before I said don't do else if because then you can only have one or the other? Well, now that's what you want. Else if, and we're going to say text file. So that solves at least this file, except for the fact that this isn't clean. So I'm going to change this to say string connection type. And then I'll say if connection type equals database, or let's be more specific, SQL. Else if connection type equals text, we can do that. Now we can come back and even make this a little bit cleaner. You know what? Let's make it cleaner. Again, this is part of that. Do you plan now or do you plan later? Let's plan now, and I'm going to add a enum here instead of a string because this is getting me a little bit nervous. Do you type SQL or you type, capital SQL or you type text file? That's just a little squirrely. So instead, I'm going to create an enum, And the way I do enums is I right click on my project and say add class, and I call it enums. Now you could create a class file for every enum, and that's fine. But what I do is I find I don't use enums that much, and instead of saying, oh, that's actually enums and where is that, I just create one file called enums and then wipe out the class inside of it and instead say public enum, let's call this database type. And we're going to say SQL and text file. So now I have SQL and text file. Get that out of there. So now I can come back over here. I can save that. Come back over here and instead say I want the database type. Now let's call it DB. And so now I'll change these again. DB double equals database type dot SQL. Or DB double equals database type dot text file. Now another way you could do this, instead of having your if, else if, and all the way down the row, you could do a switch statement. And enums are wonderful with switch statements. Because in enum, it has to know what the types are, at least currently. Now when you go to Visual Studio 2017 and the C#7 features, the switch has gotten a really big upgrade where it doesn't have to have that very limited number of items it could be in the list. It can be pretty much anything. It's pretty powerful. But in C#6 and below, in Visual Studio 2015 and below, the switch statement is limited to things like numbers, where it's very easy to say equals, so that value equals. So if I were to say, let's type it right here, switch, and I tab twice, switch on DB, and I hit enter, it's created case statements for me already. Case, SQL, case, text file. Because that's an enum. It has a limited number of types. It has, in this case, just 2. And so I added 2 case statements we could have, and then also the default case. And that's essentially the same as this if, else, if, with no else. The default will be the else at the end. But I'm going to leave my code as it is. Switch statements at this point, before 2017, are a little bit limited. I like this a little better, so I'm going to leave it as is. The great thing about programming is it really is up to you as a developer. All right, so I have this new way of doing things. Now if I come over to app.config, oops, not app.config, program.cs. It now says, oop, you got a problem. I'm not passing in 2 booleans, I'm passing in a database type, in this case, SQL. Now, if I didn't want to have that tracker library dot, I could delete that, then do my control dot here and say using tracker library, and now I can use that, I'm saying just SQL, which means that I've turned off my text files for now, I'm just using just SQL. Now, if I build this, we should have at least one more error. I go to that error, and it says, all right, for each, do this. For each IDB connection in globalconfig.connections. Well, we don't have that anymore. We only have the one. So therefore, what we can do is do this. We can say globalconfig dot, and it shouldn't be connections. So let's change this connections to be connection. I hit control dot. I'm going to say rename connections to connection. Let's go through and rename these 2. And so now they are correct. I could have just renamed this, renamed anything that broke, but that's a little bit easier, and it does know about scope, so it knows what is really calling connections and what's not. But over here, global config, control dot, connection, price. So we now know, let's just put that where it should go. So global config.connection.createPrice.model. Which connection is it? Is it SQL? Is it text? Don't know, don't care, just know we're doing it. So again, all is right with the world. If we run this, we can create a new one. Let's create prize number 4, fourth, and the prize amount is a measly $5. Create the prize, it wipes things out. If we go back over to SQL and run this again, we see that in fact, yes, we have place number 4, fourth, and $5. What that means is all those changes, they all worked, okay? And we'll get into looking at testing a little bit and writing tests to check your application as well, because that can be helpful. But for now, we just ran a test ourselves just to make sure things worked. So with all those changes that happened, we've refactored our library to be a little cleaner. We have redone how our code works a little bit to make a little more sense with some of the things we thought through. And we've also, it seems like a minor footnote now, but we've also connected to our SQL Server and inserted a value into it every time we run this create prize. And oh, by the way, we learned about output variables and how to get them back using Dapper. Welcome to Lesson 11 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to be looking at how to save data to text files. In the last video, we wired up our connection to SQL. We also did a few housekeeping things that hopefully will set us up for success going forward. Now, we need to make the text connection work like the SQL connection does, in that we take in a prize model and we return a prize model with that ID filled out. So let's look at how to do that. Here we have our solution. We can go directly to the text connector inside the data access folder. And this is what we need to wire up. So right now, this is the sample code. And just like before, we're going to delete that out. Now, again, just like with a SQL connection, the very first thing we need to do is figure out where we're going to store these text files. Now, it is plural. We're going to store our data in more than one text file. My thought is that for each one of these models, so matchup entry model, matchup model, and all the rest, for each of these, we're going to store them in their own text file. So it's essentially it's a list of that item in each file, or if you think of it in SQL terms, it's one table per text file. And text files are really cheap to make, and that's the best way of putting data in a way that's efficient in getting it back out and not confusing one with another. So we're going to store our information in multiple text files, and in this case, we'll store the prize information in the prize text file. So we need to know where to store these files. And so instead of storing a file name, we're going to store the path to where all the files go. And then all the files will be in one folder path. And that seems a little bit like the connection string. So we'll actually store this information in the same spot. So we'll go over to the app.config of the Tracker UI project. And here we have our connection string. And we're going to, in here, add a new section under configuration and call it app settings. Inside app settings, we're going to add, say, key equals file path. And the value equals, and in my case, that value equals this path right here. So C:/data/tournament tracker. No slash at the end of that. So it depends if you want to put the slash there or not. We're going to have to add that slash in when you put a file name, but I like to have this without the slash because that would be the more correct syntax for Windows. So let's leave it like that. So this now is the key and the value. So it's a key value pair, kind of like a dictionary object. So we'll be able to look up based upon this name and get this value, just like we look up by this name and get this value. The only difference is this is more generic, just any app setting, whereas this is specific to a connection string. So back over here in our text connector class, we need to start wiring up the helper methods that will allow us to talk to those text files. But before we start writing code, let's work on the plan. And I'll show you what my plan is. So here, when you say write a prize, create a prize, so save that created prize to the text file, what I'm going to do is first read the text file of the prizes. I'm going to load all the text or the prizes that are currently in that text file. And the reason for that is because I need to know what the new ID is going to be. Unlike SQL, text files don't create auto-incrementing IDs. So I'll load all the prizes up. I'll read through to find what's the highest ID and use the highest ID plus 1 as the new ID. So I'm first going to load the text file. Then I'm going to convert the text to a list of prize model. And from there, I'm going to find the ID, add the new record with the new ID, and then finally I am going to convert the prizes to a list of string. And from that, I'm going to save the list of string to the text file. Okay, so that's a lot of work, but when you're talking about text file data access, you're going to need to do some work. And that's just what it comes down to, because text files are not the intelligent systems that a relational database is. They're pretty much just stupid. And so we have to be the smart ones. With SQL, we rely a lot on SQL smarts. But with text files, it's all on us. So in this case, we're going to load in the text file, and that's going to come in as a list of string. We're going to convert that list of string to a list of prize model. We're going to find the ID, the maximum ID. We'll even say max here. We'll add the new record with that new ID, which is the max plus 1, to our list. We'll take that list then, the list of prizes, and convert it to a list of string. And then save that list of string back to the text file, overwriting what was currently there. Seems kind of simple, right? Now, these steps right here, each of them is going to be a different action, and we're going to try and keep these separate because loading the text file, that isn't based upon which type of model you're using, in this case, prize model. We just load the text into a list of string, which means that we don't have to limit that code just to this method. Converting the text into a list of prize model, yeah, it's pretty much limited to just this method. There are ways and tools we could do if we got really complicated where we could have one method convert anything to any kind of list. And if you want to pursue that path, I would recommend using a tool like AutoMapper to map from one type of object to another. Next, the find the max ID, that's pretty simple. We'll use some the link queries in order to get us the max ID. Adding the new record is just adding one to a list, but then converting that prizes to a list of string, that's going to be a custom to this type of model. But then this right here again is something that any method can do, which is save a list of string to a text file. So you got to kind of break these apart, first of all, so that each method does one thing and does it well. And then also so that other methods can use the methods that are kind of generic, the ones that don't really rely on a specific model type. Now to do this, I'm actually going to create a new class. And there's a lot of different ways you could do this new class. There's a lot of different places you could put it, and there's not seemingly a great place to put it. I'm going to put it right in data access because it kind of fits with data access. It's just as more data processing. And it's related specifically to the text connector. So I'm going to add a new class. And I'm going to call this text connector processor.cs. Now this is in the in the tracker library.data_access namespace right now. I'm actually going to change that namespace. I'm going to say .data_access.textConnector. And the reason why I changed that namespace is because I don't want everyone to get cluttered up with what I'm going to do in here. So I'm going to give it a separate namespace so that only people that have that using statement get the extra clutter this is going to create. And I'll show you why in a minute, but the key thing to point out here is these namespaces, they're really anything you want them to be. You can change them however you want as long as it's a valid string. I would stick with just letters and the dots to separate. Trying to go crazy with special characters, that can just make things ugly. But in this case, I'm going to say .textConnector. This class, I'm going to make it public static class text connector processor. And that's a mouthful, that's okay. The very first method I'm going to put in here is a public static string full file path. Takes in a file name. And what this method does, or is going to do, is it's going to take in the file name. Now the file name would look something like, let's go to prize models.csv. That would be the file name. What this is going to do is take that file name and return back the entire path. Remember that in the app.config, we have this c:/data/tournament tracker. That's the path where all of our files can be located. And currently, just so you know, that's an empty folder right here. So right now it's empty, but once we start saving things, we'll start seeing files appear here for each of our different models. So this one right here, it's going to take this, it's going to prepend this right here. So it's going to put this first, then put a slash, and then put whatever you pass in for the file name, in this case, prizemodel.csv. How do we do that? Well, this is actually pretty simple. I'm going to one-line this. I'm not always a fan of one line. Here's why. When you do things in one line, it's hard to debug because with one line, it does everything in line and you can't see what the value is at any one step as easily. But in this case, it makes sense. So I'm going to do that. Return. Give me a $ syntax, which this allows us to concatenate strings together, put them together, kind of, add them together easily in a way that's more intuitive and also more performant. So I'm going to just put my semicolon at the end just so I'm complete before I go back and start writing in here. I'm going to start off right away with my curly braces and say configuration manager. And it says, nope, I have no clue. So I control dot and say using system.configuration. So configuration manager dot app settings, file path inside quotes, and then inside those square brackets, file path, close curly brace. So what this does right here, this section, is it goes out and says, okay, configuration manager dot app settings. Well, that just happens to refer to these app settings. And it says, here's the key. Remember, it's a dictionary. So here's the key. And it's just going to say, okay, go look for that key. Oop, found it. I'll return the value. So that value comes in place of this. So now we have that c:/data/tournament tracker. After the curly brace, we need a slash. But here's the kicker. Inside of a string, if you put a slash, that's the escape character. What the escape character allows us to do is to escape out of that string to put a special item. But we don't want that. What we want is a slash. Now, if this is a regular string, we could put the @ symbol in front of the string, and it would say, no, everything inside a string is just text. It's not a special character or escape character. But in this case, we can't because we're using the $sign. So instead, we have to say slash slash. Because now we are escaping. This is the escape, the first one. The second one is what we're escaping. So it's saying, treat this next thing as a real string, and it's the slash. So essentially this will translate into 1/. All right. Next, we're going to put the curly braces again, right after, no space. We're going to say file name. We'll take that extra space out at the end. So file name is the file name you passed in. So in this case, what we do is we start off with C:/data/tournament tracker. That's this right here. Then we have this // which boils down to 1/, like so. Then we have the file name. The file name is prizemodels.csv. And that looks like a valid file path and name. And it is, except for one fact, and that is the file doesn't exist yet. And that's no big deal. So we'll take our comments out here. So this method, all it does is it says, you have a file name? Cool. I'm going to give you the full path. And in fact, we can change this to say this. So now it says this string file name. And what does that do? Well, now this becomes an extension method. And so anytime we have a string, since it says this string, that means that we're attaching to this string right here. And it says, okay, that's whatever we're passing in goes into file name. So it's going to say whatever string we have dot full file path, open close paren, will return the name of the file in the full path. So again, that's C:/data/tournament tracker / prizemodels.csv. And this will be a little easier to understand when you see it. If you're confused about extension methods, I do have a video on my YouTube channel that will help you out with that. And we're going to use a couple more of these. And this is the reason why I have this special namespace that only this file uses. Because I don't want this extension method everywhere. Otherwise, if I'm in my SQL connector and I have a string and I put a dot at the end, it's going to say full file path. Well, that makes no sense. The SQL connector doesn't need to have this text file manipulation stuff. The only place it really needs to have this is the text connector class. But in order to have these extension methods, I have to have a separate class, and it has to be static class, and each method in here that's a extension method has to also be static. So that's why I had to create the separate text connector processor.cs and why it's static and static. All right, so that gets us started by saying, okay, in here, we're just going to pass in the name of the file, which we can hard code if we want to say prize models. So we can pass that in, and it's going to give us the full path to that file. Before we leave this right here, we need to add another extension method, public static, and this is going to return a list of string. And this will be load file, and we're going to say this string file. And what this will do is it will take in the full file path, which we're going to get from here. It's going to take that and it's going to load that string. Now let's grab this over here. Let's grab this right here, because it'll be easier to see when it's in here. All right, so this right here, load file, corresponds to this first entry right here, load the text file. All right, so first thing we need to do is check to see if this file right here exists. Remember I said that this folder is empty, and that's okay, which it really should be. We don't want to create these empty files for everything we need. We want to let the system do that. So the first thing to do is say if not file, not lowercase file, uppercase file. And it says I don't know what that is, so I do my control dot and say using system.io. If not file.exists, file. Okay, so what that is, oops, there we go. What this is, it says this method right here, file, which is built into Microsoft, it's in the system.io namespace. So if system.io.file.exists. So the exists returns a Boolean, a true or false. We pass in the full path to the file, and it's going to check to see if that file already exists. And I'm saying if it doesn't exist, that's the not in front of it. If not exists, now if that confuses you, or if you really think you might skip over this, you can most definitely take this out, and at the end here, before the last paren, put double equals false. If file exists equals false. Okay, it's the same thing. And in fact, there's no performance hit to doing this versus the not. Therefore, if that's what you're comfortable with, please by all means do that. You will see, got rid of my F there, you will see this more commonly in the production environments of businesses. It's just a more accepted syntax because it's a little cleaner, a little tighter, and it's what we do. So you're going to see this, and a lot of people will swear by this and say that's the only way you do things. It really doesn't matter, except if you're trying to match somebody else's standards. If you're just learning how to develop, do what's going to make sense to you. Okay, that's my little soapbox. Just do what makes sense to you. Don't get suckered into the, well, this is the best practice for when I'm an Uber developer. That's great, but if it's going to limit you from becoming a good developer, don't do it. Do what's going to get you to the next level. Don't try and jump 4 levels up all at once. Okay, so the file does not exist. We can't read from it. In that case, return new list of string. But if the file does exist, we're going to bypass this right here and come down here. And we're going to say return file dot read all lines. Again, baked right in. Here's the file. The last thing to do is say to list, open, close paren, and semicolon. So now this method takes in that full file path and returns back a list of string. And that list of string represents all the lines in the file. The first line is in the first value, the first entry in the list, and down it goes. So that is this right here. Next, we need to convert the text to a list of prize model. Now, this is going to be a method that is specific to prize model. We're not going to have a generic method for this, but I'm still going to put it in this file here because it makes sense from a standpoint of I'm going to use it as an extension method. The eventual goal here is I want to be able to chain these together so I can read it very easily, where it's going to say, give me the full file path of this file, and then load that file, and then convert that file to a list of prize model, and so on and so forth. So down here, I'm going to say public static list of prize model. I have to use my using statement, so control dot and then hit enter. And we'll call this convert to prize model. Let's make it plural, prize models. And say this list of string lines. So it's going to take in a list of string. Where would I get a list of string? Well, that's the lines from the text file right here. It's going to spit out a list of prize model. That's the eventual goal. Now, again, it's an extension method on the list of string type. So here's how this works. We're going to start off with our output. List of prize model is our output. And we'll initialize that output. Then we're going to say a for each. String line in lines. When you're doing a for each, it's okay to have a single letter if you want, and we'll probably do that at some point, but just to make things shorter, because you know what it is, it's a line in the lines, especially when you have user in users. That gets a little confusing, so I might do user u in users. But in this case, we use line. That's fine. And it's a string. So now I'm going to say string array. I'll say calls for columns equals line.split on single quotes here, not double quotes, and a comma in between. What am I doing here? Well, if you watched my text files video, you'll know that for each line, I'm going to have it comma separated, like a CSV file. In fact, we're saving it as a CSV file. We'll see that in a minute. But for each line, I'm going to have these entries separated by commas. So I will split the values. I will split the line on the comma value. And that's going to put it into an array of string called calls. And now I can say prize model, I'll call it P, equals new, not sure why it's models.prize model, but we can take that off. And we will say P dot ID equals calls array position 0. And you may say, how do I know that we're at array position 0? Well, because that's the first one I write, that's the first column. You're going to have to know what your columns are and how they line up. And that's a little ugly, but that's what we're going to have to do. Now, it's going to yell at me here because this is a string. I'm trying to put it into an integer value. Now, there's a lot of ways we can deal with this, but remember I said that we're going to deal with exception handling in a different video, but that sometimes you want your application to crash rather than trying to make it limp along with half-formed data. In this case, that's exactly what I want to have happen. I don't want to worry about trying to protect the application from crashing. I'll let something higher up the food chain handle that. And instead, I'm going to crash if things don't work, which means I can say int.parse, and then in parens, put this string. Now, int.parse is going to take the string and convert it to an integer. And as long as that's like a 1, 2, or 3, some kind of integer, that'll work. If it has the value of Frank in that field, it's going to crash the application because Frank is not a number. So that's just something to keep in mind. This is going to crash if the data is not correct. Now, who writes this file? Only this application, in theory. So when this application reads from this file, it should be correct data. But you never trust things to go as planned. But in this case, it's going to have to blow up until I can put some exception handling in that's a little more intelligent and probably farther up the line, because I want this whole method to crash if it can't convert one line. Because if there's bad data there, we've got a big problem. We need to stop right where we're at. We can't continue on with half good data. All right, P dot, the next thing in line, the next column would be the place number. And the place number is also an integer, so int dot parse calls 1. Next, we've got P dot place name, and that's a string, so that's easy. Calls 2. P dot prize amount. Now, prize amount is a decimal because it's money. So therefore, we say decimal dot parse calls 3. Again, same thing. If it's not a decimal, it's going to break. P dot prize percentage. That's a double. So double dot parse calls 4. So there we have our model being built based upon the 1, 2, 3, 4, 5 columns in this text file. And again, they have to be in the correct order, and they have to have good data. And at the end of all of this, we say, we take our list, output dot add P. And then at the very end, we return output. And so what's happening is we're going to loop through every line in our text file. And you may say, whoa, 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 we don't have a text file yet. So what are we looping through? Well, remember we said return that new list of string. Essentially, a list of string that's initialized but has no records. Therefore, when we say for each line in the list, well, there's no lines. Therefore, we skip right over and return the output, which is an empty list of prize model. Perfect. Now we can come back up here and look at convert the text to a list of prize model. Done. Now we need to find the max ID. Well, that seems like something that the method in the text connector could do, since we're doing an insert, and an insert is unique to needing to have that ID, because an update would already have the ID, and it's just going to change some values in that row. So therefore, that's pretty unique to this create prize right here. Therefore, we're going to put the logic in here. So how do we put this logic in? Well, first we need to add the namespace. And the namespace is tracker library.dataaccess.textConnector. I'm going to copy that. Let's come over here and say using that namespace. And immediately I notice I have a problem. Tracker library.dataaccess.textConnector. Does that sound familiar? How about tracker library.dataaccess.textConnector? So now my namespace is the same as a class name. Would that survive? Sure. We just couldn't use a using statement. But that doesn't really seem like it's a helpful thing for me. So instead, I'm going to say, let's change this namespace. Again, we can change these at will. Text helpers. And so now I can come over here and say, it's not text connector, it's text helpers. That looks better. Okay, here we need to start working with our file. So first I'm going to come up here to the class level. All right, we're going to say private const string. We're going to call it the prizes file equals prize models.csv. Now what is this? Well, it's a private constant, meaning this value, the value inside this variable right here, will never change. It's going to be prizeModels.csv forever. So now I can take this variable and use it as a constant wherever we go, and we know that it's the same value everywhere, and we didn't accidentally overwrite it somewhere. It's also a little more efficient. That's the const, making it a constant. Now the notation is a little different in the fact that it's private and it's a variable of a type, but yet we have the Pascal notation of the uppercase first letter of every word, not just the first letter of the second word, with the first one being lowercase. So typically if this was a private string, this would be a lowercase p. Because it's a private constant string, the notation is uppercase. I'm not a huge fan of that just because it is a little confusing with anything public. These things are publicly used, and so we do methods, we do class names, we do namespaces, and they're always Pascal notation, whereas private variables are always the camel case, where the first letter is lowercase and all the other first letters of words are uppercase. So it's not a favorite, but at the same time, this is the most preferred way in the industry of doing things. And I typically try and keep my style as close as possible to industry standards or the generally accepted practices, just because it's much, much easier than to transition into a new location and not have to change my style dramatically. So with that being said, prizes file. And that's the location where we're going to store our prizes. Now I could say the full path right there, but what would that do for me? Well, it'd lock me down to that particular path unless I change code. Whereas right now, in the app config, we can change that at any time and relocate where our files are. That means we can actually put our files onto a network share or onto a different drive entirely, and this application would still work just by changing the app.config location for file path. So we want to keep this as it is, and we'll have a few constants here, one for every model, but I'm not going to add them now. I'm going to add them when I need them. Just makes more sense that way. You don't accidentally create duplicates. So with that being said, I need to take my prizes file dot, and this is where we're going to use our extension methods. Our first extension method is the full file path. So dot full file path. That's an extension method. And I don't pass anything in because it's going to take the first value, the one that says this, from this string right here. So that's going to convert that to a full file path. But I'm not done. I then hit dot. And now that I have a full file path, I can do this load file. So Control J to pull this back up. Load file. Which file? Well, the full file path of this file. I don't pass anything in because that's this value right here is what gets passed into here. And then I say dot convert to prize models. So it takes this list of string that comes out, or I convert that to prize models. And do I pass in anything? No, because that list of string is all I needed. Open, close, and now at the very beginning, I can say list of prize model prizes equals, and have that full section right there. So it takes the prize file, it finds the full file path, it loads the file, it converts that to a prize model list, and returns that to my variable. See how kind of compact that is? And yet it's also readable, and yet it's doing 4 different things. Well, 3 different things. 3 different methods on that data, and it's chaining it all together. So now I have in one line my list of prize model from my text file. Next, I need to, and that's these 2 lines right here are now done. And in fact, I could just take this and put them right above, load the text file, and convert the text file to a list of prize model. So there's the first two steps done. Now for this next one, I'm going to say int current ID equals prizes dot order by descending. So I'm going to order this list descending by x equals greater than x dot ID. So what this does is it takes my list and says, okay, I'm going to order by descending by the ID property. So if I have two records, one of the ID property of 1 and one of the ID property of 2, 2 is greater than 1, therefore 2 comes first because we're going 2 then 1 because that's descending order. So now I have my list ordered, but that's not good enough because that's not an integer. Instead, I then say, give me my first value. And what does that do? It gives me that first record, which is the record that has the highest ID. And then I say dot, in the list I have ID. And I'll say plus 1. What that does is it finds the ID of the highest ID in a list. So if we have 3 IDs in our list of prizes, ID of 1, 2, and 3, it's going to find the record the ID of 3, and then get just that ID, so that's just a 3. We're going to say 3 plus 1. Now the current ID is 4. And that current ID is the one we're going to use to write the new record. So I'm going to say model, and that's what we're passing in right here, model.id equals current ID. Now, to be totally complete, what you should do then is say current ID plus equals 1, meaning now the ID is moved up 1 because we've used that ID. And that would be in case you wanted to write more than one record at a time to this list. But in this case, we don't, so we'll go ahead and not add that extra code since it's not necessary. And now we have our record we want to add, so we say prizes.add model. So we've added our new model with the new ID to our list of prizes. So that's find the max ID. We're going to grab that, and we'll put that there. Then we're going to add the new record with the new ID, and that's right there. And now we need to convert the prizes to a list of string and save the list of string to a file. That sounds like we're going back to our text connector processor and doing some more work. And writing will be a little bit easier in the fact that we'll just do one method and we'll do everything. Just because writing is so easy. We're going to say public static, and we'll say void because there's nothing we need to return. We're just going to write these files. We're going to call this save to prize file. Call it save to prize file. We're going to pass in this list of prize model. We'll call it models. And then we need to pass in also the file name. Okay, so we passed in our list of models, and that's our, this is an extension method based upon this list of models. So therefore, when we're over here, we can say prizes dot save to prize file and just pass in the file name. So now we have its list. We can say we need to convert this to a list of string. So list of string lines equals new. Wow, messed that up. List of string lines equals new list of string. That's better. Then we're going to do a for each. And this is going to be a for each on our prize model. I'm going to call this P in models. So I called it P because I want it to be as short as possible because of how I'm going to have to create this entry. Now I have this list of string here, and C# is great about writing a list of string to the database, so I will use this, but I have to add a line for every single model. So I'm going to say lines.add. I'm going to do my $ double quote syntax, and I'll put my semicolon at the end and come back here. Now, what's the first thing? p.id, comma, make sure not to put spaces where it's actually going to count it. Keep the spaces limited to inside your curly braces if you want to use them at all. Next we have p.place number. And the order is important here. Remember, this order here is the order up here. So you can even look up here for your kind of a cheat sheet. That's always a good thing to double check. So next is p.place name. And then comma, p.prize amount, comma, p.prize percentage. So I have the ID, a comma, the place number, a comma, the place name, a comma, the prize amount, a comma, and the prize percentage, no comma at the end. And that's how you do a comma separated line. Now it's going to loop through every line in my list of models. And so now at the end of that, I have a list of string that represents all of my models. So now all I do is say file.write all lines. And it's going to ask for two things. First of all, the path. So I'm going to say file name. You're going to say, but wait, that's not the path. No, it's not. Now we have to say file name dot, and what's it's full file path. So Control J down here to open that list back up. Full file path, that's the file name. And the contents is, right now, if you look, it says it's an array of string, but if you do this little arrow here, you can see it's IEnumerable of string. If you keep going, you can see other options as well. We're going to use this second one, the IEnumerable of string. And list is an IEnumerable, therefore list will work. Let's zoom back out here. We can say lines. And guess what? That's all we need to do. So we take our models and our file name. We take the models, we convert them to a list of string. We take our file name and convert that to the full file path. Then say write all lines. Here's a full file path, and then here are your lines to write. And we're done. And with that, we come back over here. We can actually just move this up. And then right under here, we call this the save to prize file. Oops, let's not do that. I accidentally double-clicked here and it popped it into a new window, which will allow you to drag it to a second monitor if you want. I use that quite frequently when I'm trying to both read something like this right here. You know, I'm reading save to prize file and coming back over here and using that. Because I try to remember things, I try to make sure and double check and verify by reading. It just makes a whole lot less of a mess later when you go, oops, I forgot that, or I transposed something. So I just don't remember things intentionally. I actually go back and double check. So I could drag this tab into a different monitor and read it while I type. But in this case, with one monitor, it's not as easy to do. So I'll just go ahead and go back and forth. I could also split these, right click on a tab and say new vertical or horizontal group. And that'll allow me to see two files at once. But in this case, I'm just going to come back over here and say save to prize file. Okay. And so I'm going to say prizes dot save to prize file. It does take something in because we have two parameters. The first one comes from here, the prizes. The second one is the file name. And what's the file name? Well, it's the prizes file. And notice the little icon right here indicates that it is a constant. So, with that being said, we have now saved our prizes back to our text file. We've overwritten that text file. You see back over here, this write all text, write all lines. If you notice the comment, what it does, it says it creates a new file, writes the collection of strings of the file, and then closes it. It writes a new file, meaning it's going to overwrite the file that's already there. So if you didn't want that, that'd be different. But in our case, we want to blow the original file away, start over. So now we're almost done. We have this red squiggly here, and it says, hey, you're not returning a value. What is the value to return? Well, return model. Why? Because the model is what we added that ID to, and now it's the prize model fully formed with that ID. So now you can refer to anything else we do by that ID, and we'll know we mean this particular record. Now, how do we know this is going to work? Well, we need to test it. Again, we'll cover unit testing in a future video, but for now, I want to get into actually just running this thing. So let's come down to our program.cs, and we have this initialized connection. We're going to use a data type of SQL. No, we're not. Control J. We're going to use the text file instead. Now we're saving the text files. Again, there's nothing in here in any of these text files. There's no text files. So let's start this application. And it's going to start off screen like it always does. And I'll pull it over. I'm going to open my folder here and just put it next to it. And I'm going to say place number is, let's give it place number 2, place name of second place. And the prize amount is 50. Create prize. And it blows up on us. Excellent. And it says, sequence contains no elements. Wah wah. Why is this a problem? Well, we said we didn't care if our text file was not there because we would just add that first model to our list and then save that list of 1. But we have a problem. We're trying to get the ID. And we're assuming, and that's where you get into trouble, we assumed that our list of prizes had at least 1 record. We could then sort by the IDs. It does not when there are no records. How do we fix this? Well, first we stop. And then we say, let's copy this. I'm going to say that this equals 1. And then I'm going to come down here and do an if statement. If. And I'm going to say prizes dot count is greater than 0. So what I've said is the initial value of the ID is 1. Now normally the initial value would be 0. But I want it to be 1 because if the prizes.count, the length of our list, is 0, meaning this is false, it will not do this, and it will put the ID of the current ID, that'd be 1, into the model.id. So be the first record. Now over here you see that I have the value plus 1. Think of this as 0 plus 1. That would be the equivalent of what I'm doing down here. But it's kind of silly to do math on an assignment like this when I can just do that. So that's why I'm going to do that. That should take care of our bug. So now if the prizes count, the number of records and prizes is not 0, we're going to find that ID. Otherwise, we'll skip over it and put the ID of 1 into model.id. Let's run that again. I'll bring up my folder and also my file. And I'm going to do this again. Say, let's do third. I always like to change the value that I test from the previous crash just to make sure that the old crash information didn't somehow slip into. Now, that's the wrong place for third. That should be 3, and this should be third. And the prize amount for this we'll say is 25. We're going to create prize. And look at that. We have a file over here. And if you notice on my system, it says, hey, that's a Microsoft Excel file. It's actually a Microsoft Excel comma separated values file. Well, sure it is, but I'm actually going to open this with Notepad. And look, we have 1, that's the ID. 3, that's the place number. Third is the place name. 25 is the prize amount. And 0 is the prize percentage. That's awesome. We're going to close it back out, and I'm going to say 2 for second. Place name is second. Prize amount is 50. We'll leave prize percentage alone. We'll create that. We're going to do it again for first. Prize amount is 100. I'll create that, and I'm going to create fourth place just to exercise my prize percentage. And we're going to say this is 5%. And create the prize. Let's open this up again. Open with Notepad. And look, I have 4 records. Notice the IDs are 1, 2, 3, 4. The second column is not the ID, that's the place number. 3 for third, 2 for second. Let's zoom in here. 1 for first and 4 for fourth. Notice that the first 3 have the value of 25, 50, and 100 in this column right here, whereas the fourth place does not have a value in that column, it has a 0. And instead, we have a 5 in our percentage column. So it's working. We're saving our values to our text file. And in fact, we could open this up in Excel if we wanted to and actually add new columns. I recommend you be careful with that because this is very strict about how it puts values in. And if you make a mistake with a typo or adding an extra column or something weird like that, you might actually cause an issue where your application crashes. So let's not crash our applications just yet. We'll do that later when we're trying to work with exceptions. In the meantime, we now have a working application that can either save to our text file or to SQL. Before we go, I want to point out that in our text connector, we have all of these extension methods. So this is a string dot full file path. But if I were to go to SQL connector and come in here and just give a string, whatever it is, test, and then say dot full file path, it's going to say, no, I have no clue what that is. If I hit control dot, it's going to say add the using statement for tracker library.dataaccess.text helpers. Now I'm not going to do that, but that just goes to show that all those extension methods aren't on our values, our strings and our lists and all the rest. They're not there unless we add that using statement. Let's just get all the way out of there. All right, so unless we add our using statements, which up here we have our using statement, when we add this using statement, we get all these extension methods. When we don't get them. And that's actually a really good benefit because as we go on, if we have lots of these extension methods, we can double and triple the size of that list of possible options, and we might even step on our own toes where we have 2 methods with the same name that do something different. And so the best way to make sure that we keep those separate is to keep them in separate namespaces and only pull in the namespaces of the extension methods we really need. Welcome to Lesson 12 in the C# from Start to Finish course. My name is Tim Corey, and today we're going to start working on the Create Team form. In our last couple of videos, we worked on getting the data access set up for our Create Prize form. In this video, we're going to do basically the same thing we did in the prize form, only this time it will be to add a new team member or a new person. And before we get to the code, I want to point something out. And this is something I touch on often, but I want to drive this point home. Don't get overwhelmed by complexity.